Now we'll study binomial series. Now binomial series is any series having binomial coefficients. Now in order to study binomial series, there is certain prerequisites that we must know. So I'll assume that you know the expansion of a plus b to the power n. We can write it as r varies from 0 to n, ncr e to the power n minus r b to the power r, or its expanded form, which is nc0 a to the power n b to the power 0, n minus 1 e to the power n minus 1 b, and this series continues up to ncn, or the expansion of 1 plus x to the power n, which we'll write it as summation r varies from 0 to n, ncr x to the power r, which is nc0, nc1x, nc2x square, ncn x to the power n, x plus 1 to the power n. Same series, here I have taken x plus 1. So here will be in the decreasing powers of x. So x to the power n, n minus 1, and n. So which is x to the power n minus r. And finally 1 minus x to the power n, which will be ncr minus x to the power r, which is nc0 minus nc1x plus nc2x square. So alternate plus minus sign, and finally it will be minus 1 to the power n into ncn. Now, if we'll know all these series, then we'll be able to solve most of the problems in binomial series. So let us take up an example. Now, the first kind of questions in binomial series are the questions where we are actually given expanded form of binomial series in terms of summation. Say, for example, suppose I am given this expansion, which is summation r varies from 0 to 100, 100 cr, x minus r to the power 100 minus r, 3 to the power r. So if I look at this summation is actually nothing but ncr, a to the power n minus r, and b to the power r, where r varies from 0 to n. So basically it is nothing but it is a plus b to the power n. Now what's a? A is x minus 2. What's b? B is 3. And what's the value of n? N is 100. So it will be simply x minus 2 plus 3 to the power 100. So answer to this series is simply x plus 1 to the power 100. So what they'll do is they'll give you the binomial expansion in expanded form or in summation form, and you have to simply write it in its compact form, which is a plus b to the power n. Let us take up another example. Say for example, so the question is we need to find the sum of this series, which is summation r varies from 0 to n minus 1 to the power r, ncr, 1 upon 2 to the power r, 3 to the power r upon 2 to the power 2r, 7 to the power r, 2 to the power 3r. So it goes up to n terms. So what I'll do is I'll multiply this expression with each of the term, and I'll take the summation separately. So I'll write it as summation r varies from 0 to n, and this is, I'll write ncr first, ncr minus 1 to the power r, 1 upon 2 to the power r. For the second one, I'll write summation r varies from 0 to n, ncr minus 1 to the power r, 3 to the power r, and 2 to the power 2r, I'll write it as 4 to the power r, and then plus summation r varies from 0 to n, and then ncr minus 1 to the power r, 7 to the power r, and this 2 cube is 8, 8 to the power r, and this series will continue up to m terms. So I'll write it as summation r varies from 0 to n, ncr, I'll multiply this one inside, so there'll be minus 1 by 2 to the power r plus summation r varies from 0 to n, ncr, and here if I'll multiply this minus 1, so I'll get minus 3 by 4 to the power r, summation r varies from 0 to n, so there'll be ncr minus 7 by 8 to the power r, and will continue up to m terms. Now when I look at each of this expression, which is ncr x to the power r, so it has a summation of r varies from 0 to n, ncr x to the power r, so this in fact is nothing but 1 plus x to the power n. So I'll write it as 1 plus, and what's the value of x here? 1 by 2. So 1 minus 1 by 2 to the power n. Next one, here the value of x is minus 3 by 4. So it will be 1 minus 3 by 4 to the power n. Next one is 1 minus 7 by 8 to the power n. And this series will continue up to n terms. So this is 1 upon 2 to the power n, 1 upon 4 to the power n, 1 upon 8 to the power n, and this series it continues up to n terms. Now this series is actually nothing but a geometric progression. So I need to find the sum of this geometric progression. So what is the first term? First term here is 1 upon 2 to the power n, and then 1 minus, what is the value of r? R is 1 upon 4 to the power n upon 1 upon 2 to the power n. And number of terms is simply n. And then 1 minus 1 upon 4 to the power n and 1 upon 2 to the power n. So if I'll simplify, I'll get it as, so 1 upon 2 to the power n, 1 minus, so here it will be 2 to the power n will cancel, 1 upon 2 to the power mn, and here will be 1 minus 1 upon 2 to the power n. So if I'll take LCM and if I'll simplify, so I'll write 2 to the power mn minus 1 upon 2 to the power n minus 1, and it will be 2 to the power m into n. Now the second method in binomial series is method of particular values. So we can take up any binomial or standard binomial series and then we can start putting in the values of x, or maybe if we'll take a and b separately, then we'll put the different values of a and b, and then we can get the requisite series. Say for example, suppose the question is, I need to find the sum of the series nc0 plus nc1 plus nc2 and then plus ncn. So I need to find the sum of the series. So what I know is, I see all these coefficients nc0, nc1, nc2 and ncn, they occur in the expansion of 1 plus x to the power n. So what I'll do is, if in this expansion, if I'll put x as 1, then on the left hand side I'll get 2 to the power n, and here I'll get nc0 plus nc1 plus nc2 and then plus ncn. So basically this series, it is nothing but it is the expansion of 1 plus x to the power n when the value of x is simply 1. So answer to this series simply will be 2 to the power n. And this is one of the very basic yet very important binomial series. nc0 plus nc1 plus ncn is 2 to the power n. Now suppose if I say 12c0 plus 12c1 plus 12c2 plus 12c12, I'll simply write that is 2 to the power 12. So that is true for any value of n. Even if it is, suppose n plus 1 c0, n plus 1 c1, n plus 1 c n plus 1, I'll simply say it is 2 to the power n plus 1. So c0 plus c1 plus cn will be simply 2 to the power n. So whatever may be the value of n, maybe n is 12 or n plus 1 or any other value, I'll simply use this series, which is very simple, at the same time very fundamental. Now what if I have to find the second series, which is nc0 minus nc1 plus nc2 minus nc3, and it continues up to minus 1 to the power n ncn. Now we know that this again involves c0, c1, c2, but with alternate plus or minus signs. So I know that here it's an odd power of x, so with c1, c3, and with c2, c4, it'll be an even power of x. So if I put x as minus 1, I'll get c0 minus c1 plus c2 minus 1 into x to the power n. So in this expansion, I'll simply put the value of x as minus 1. So if I put value of x as minus 1, I'll get c0, which is nc0 minus nc1 plus nc2 minus nc3, and finally it will be minus 1 to the power n ncn. And here if I'll put x as minus 1, so 1 minus 1 will be 0. So answer to this second series is simply 0. Now there will be many more series that can be worked out by adding or subtracting the given two series. So if I'll add the two series, then what I'll get is, I'll get 2 times, and then c1 gets cancelled, c3 gets cancelled, I'll get nc0 plus nc2 plus nc4, and this value, so if I add 2 to the power n plus 0, so there will be simply 2 to the power n. So now I'll cancel this 2 with 2 to the power n. So what I'll get is, I'll get nc0 plus nc2 plus nc4, and that is 2 to the power n minus 1. In the same way, if I'll subtract these two series, so if I'll subtract second from first, now in this case, c0 will cancel, c2 will cancel. So all I'm left with is even number terms. So there'll be 2 times nc1 plus nc3, and it will continue, and there'll be 2 to the power n. So again this 2 will cancel. So here again I'll get 2 to the power n minus 1. So sum of binomial coefficient leaving one at a time, c0, c2, c4 or c1, c3. So that's equals to 2 to the power n minus 1. So this series, it is 2 to the power n minus 1, c0, c2, and again this series c1, c3, its value is 2 to the power n minus 1. So we can work out binomial series just by putting in the different values of x. So now what about this series nc0, nc1 into 3, nc2 into 3 square, ncn into 3 to the power n. So again if I look at the standard series, which is 1 plus x to the power n. So this is c0, c1x. So for brevity, I'm going to write NCR as simply CR. C1x plus C2x square and Cn and x to the power n. So if I'll compare this series, so C0, then C1x, so which is 3, then x square is 3 square, x to the power n is 3 to the power n. So all I need to do in this series is, I'll just need to put the value of x as 3. So if I'll put value of x as 3, I'll get C0, C1 into 3, C2 into 3 square, and Cn into 3 to the power n, and it will be 1 plus 3, which is 4. So answer to this series will be simply 4 to the power n. So let us take another series which is 21C0, 21C1, 21C2 and 21C21. So this is a simple series. We have done this series previously, right? So NC0 plus NC1 plus NC2 plus NCn is simply 2 to the power n. So I'll simply write this value is 2 to the power 21. But they may not ask you the sum of complete series. Now what I know is binomial coefficients, they are symmetric. So that is 20C1 is same as 21C21. 21C1 is same as 21C20, 21C2 is same as 21C19. So they may not ask you the complete series. They may give you a question where they are going to give you just half the series. Say for example, suppose they want you to find out 21C0 plus 21C1 plus 21C2 and up to 21C10. So you have to find the sum of this series. Now what I do know is, so in this series there are 22 terms. And each of the term, it is symmetric. So 21C0 is same as 21C21. 21C1 is same as 21C20. So here I am given these 11 terms. So what I can say is, I'll take the series. So 21C0, 21C1, 21C2, and I'll take it up to 21C10. Now, what about 21C11? So NCR is same as NCn minus R. So 21C11 will be same as 21C10. So 21C12 will be 21C9. And then 21C21 will be 21C0, and this value is equal to 2 to the power 21. Now, this series is from C0 to C10, and this series is also from C0 to C10. So all I need to do is, I'll write it as 2 times 21C0, 21C2, 21C10, and that is 2 to the power 21. So now I'll cancel this 2. So now it will be 2 to the power 20. So answer to this series will be 21C0, 21C1 plus 21C2 up to 21C10, and this is equals to 2 to the power 20. So they may not ask you the sum of entire series. They may ask you the sum of half the series, because we know that binomial coefficient, they are symmetric. So binomial coefficient from the beginning is same as binomial coefficient from the end. So now the question is, we need to find the sum of the series, which is 20C0 minus 20C1 plus 20C2 minus 20C3 up to 20C10. So I know like binomial coefficient, they are symmetric. So 20C0 is same as 20C20, so with alternate positive and negative sign. So I know my basic series is going to be 20C0 minus 20C1 plus 20C2 minus 20C3, and then it will be minus 20C9 plus 20C10, then minus 20C11, and then it'll continue up to 20C20, right? So I need to find the sum of half the series. Now 20C0 is same as 20C20, 20C1 is same as 20C19, but here when the n is an even number, so n in this case is 20, right? So number of terms is 21. So this series, it's symmetric about this middle term, and this middle term will be 20C10. So there is no pairing for this middle term. So I know sum of the series NC0 minus NC1 plus NC2 minus NC3. This sum is simply 0. Now this series from 20C11, because 20C9 is same as 20C11 and 20C0 is same as 20C20. So they'll pair up with the first series. So I'll simply write it as 2 times 20C0 minus 20C1 plus 20C2 and minus 20C9, and then I'm left with this middle term, which is 20C10, and this should be equals to 0. Now I need to find sum of this series. So I'll take it on the right hand side. So I'll simply write 20C0 minus 20C1 plus 20C2 and then minus 20C9, and this value is minus 1 by 2 into 20C10. So just remember that if the number is even, so then there'll be a middle term which won't have a pair in the given series. Now there may be some questions in binomial series where we need to put complex numbers in this method of particular values. Say for example, suppose I have to find the sum of the series nc0 minus nc2 plus nc4 minus nc6, or I have to find the sum of the series nc1 minus nc3 plus nc5 minus nc7. So here we have skipped one term. So c0, then we have skipped c1, then c2. There's no c3, c4. Again here it's c1, then c3, then c5 and c7. The problem here is it is with a minus sign. So we know that in the expansion of 1 plus x to the power n, it is nc0 plus nc1x, nc2x square, nc3x cube, nc4x to the power 4, nc5x to the power 5, nc6x to the power 6, and we'll continue up to the last one, which is ncn into x to the power n. Now so for the first series, I need to eliminate these terms. So which is x cube and x5, and it can be done. I can consider 1 minus x and then I can add them, so then it will be eliminated. But the problem here is if I get nc0, I'll get plus nc2 into x square. So when I get this x square, I cannot make it negative with any real number. What I know is, I know that iota square is minus 1. So what I'll do in this question is, I'll put the value of x as iota. So if I'll put x as iota, I'll simply write it as 1 plus iota to the power n. Now it will be c0, and then it will be c1 iota, c2 iota square, c3 iota cube, c4 iota to the power 4, c5 iota to the power 5, c6 iota to the power 6. It will continue, and cn then will be iota to the power n. Now we know that this is c0, it is c1 iota. Now iota square is minus 1, so there will be minus c2. Now iota cube is minus iota, so there will be minus c3 iota. Iota to the power 4 is simply 1, c4. Iota to the power 5 is simply iota, so this is c5 iota. Then minus 6 c6, and this series it will continue. And on the left hand side also, when I look at this 1 plus iota, I know for this its modulus is 1 plus 1, which is root 2. And its argument is pi by 4. So I'll express 1 plus iota in terms of polar form. So I'll write it as root 2 cos pi by 4 plus iota sine pi by 4 to the power n. So I can write it as 2 to the power n by 2, and then cos pi by 4 plus iota sine pi by 4 to the power n. And here what I'll do on the right hand side is, I'll take the real terms together. So if I'll take real terms, so there is c1 minus c2 plus c4 minus c6. So that is the series that I'll need in the first expression. And then I'll take imaginary part also. So that its imaginary part will be iota, and then will be c1 minus c3 plus c5. So that is this series. So the series that I'll need, it is the real part and the imaginary part on the right hand side. So I'll need to find real and imaginary part on the left hand side also. Now we know that it is cos theta plus iota sin theta to the power n. So if I use de Moivre's theorem, it says cos theta plus iota sin theta to the power n is simply cos n theta plus iota sin n theta. So I can write it as 2 to the power n by 2 cos n pi by 4 plus iota sin n pi by 4, and this is c0 minus c2 plus c4 minus c6, and then plus iota, which is c1 minus c3 plus c5. So now I'll compare its real part with the real part on the left hand side, right? So real part on the left hand side is 2 to the power n by 2 cos n pi by 4. So answer to this first series will be 2 to the power n by 2 into cos n pi by 4. And for the second one, its imaginary part, so c1 minus c3 plus c5, c1 minus c3 plus c5. So there will be the imaginary part on the left. So there will be 2 to the power n by 2 into sine n pi by 4. So at times we may need to put complex numbers rather than real numbers to find the sum of this series. So answer to this one, first one is 2 to the power n by 2 cos n pi by 4. And for the second one, it is 2 to the power n by 2 into sine n pi by 4. Now, in the same series, there can be another question also. And the question could be nc0 minus nc2 plus nc4 whole square plus nc1 minus nc3 plus nc5 whole square. So basically, it is real part square plus imaginary part square. I know that under root of real part square plus imaginary part square is modulus value of that complex number. So all I need to do is, so for this series, I'll simply take modulus of this complex number. So here I'll write mod of 1 minus iota to the power n, and here I'll simply write c0 minus c2 whole square and plus c1 minus c3 whole square. So that is under root of real part square plus imaginary part square, and for this one, its modulus value is under root of 2 to the power n, and this is under root of c0 minus c2 whole square plus c1 minus c3 whole square. So if I'll square it, I'll get this value as simply 2 to the power n. And also if I'll square it and if I'll add them, so I'll get 2 to the power n, 2 to the power n will be common, and then cos square theta plus sin square theta will be 1. So answer to this series will be simply 2 to the power n. Now another example of binomial series that will require use of complex numbers is the kind of series such as nc0 plus nc3 plus nc6. Now in this series, we have all the terms which are in which the power of x is the multiple of 3, and we do not have any other term. So what I know is in complex numbers, there are 3 cube roots of unity. So it is 1, omega and omega square. And with 1 omega and omega square, we know that value of omega cube is 1, and 1 plus omega square is simply 0. So what I'll do is, in this series, I'll put the value of x as 1. And we'll get to know like why. So once we are done with this question, you will understand why we are putting x equal to 1 in this. So what I'll get is 2 to the power n will be c0 plus c1 plus c2 plus c3, c4, c5, c6, and we'll continue. Now I'll take another series, and here I'll put x as omega. So I'll put x as omega, so I'll get 1 plus omega to the power n, and here I'll get c0, c1 omega, c2 omega square, c3 omega cube, c4 omega to the power 4, c5 omega to the power 5, c6 omega to the power 6. So I'll simplify this a bit. So 1 plus omega is minus omega square. So I'll write minus omega square to the power n, and here will be c0 plus c1 omega plus c2 omega square. Now omega cube is 1, so I'll write this as c3. Now omega to the power 4. Now omega to the power 4 is omega cube into omega. Omega cube is 1, so it will be simply omega again. So there will be c4 omega, similarly c5 omega square, and again c6 omega cube square, which will be 1. So that's how I'll write it. Now I'll take another series, and for that I'll put x as omega square. So if I'll put x as omega square, I'll get it as 1 plus omega square to the power n, and it will be c0, c1 omega square, c2 omega to the power 4, c3 omega to the power 6, c4 omega to the power 8, c5 omega to the power 10, and c6 omega to the power 12. So I'll simplify it again. So if I'll simplify, I'll get c0 and then c1 omega square, c2 omega, c3 omega cube is 1, c4 will be omega square, c5 omega, and then it will be c6, and 1 plus omega square is simply minus omega. So I'll write it as minus omega to the power n. Now I'll add the 3 series. So I'll add first, second, and third series. So I'll write 2 to the power n plus minus omega square to the power n and plus minus omega to the power n. Now when I'll add them, so I'll get this c0 plus c0 plus c0. So there'll be 3 times c0. Now what about c1? So I'll get c1 omega, and c1 omega square. Now I know 1 plus omega square, it'll be simply 0. So there'll be no c1. In the same way, if I'll take c2 omega square, and c2 omega. So again, 1 plus omega square will be 0. Now again with c3, and c3. So there'll be 3 times c3. Now for c4, 1 omega square, 1 omega square. Then it is 6, and 6. So there'll be 3 times c6. So answer to this series, so I'll take 3 common. So this is 2 to the power n plus minus omega squared to the power n minus omega to the power n. This is 3 times C0 plus C3 plus C6. So I'll divide it with 3. So answer to this series will be 2 to the power n and then plus minus omega squared to the power n plus minus omega to the power n upon 3. So depending on the value of n, so I'll get separate results. So this is another way or another case where we need to use complex numbers or particular values in terms of complex numbers, not real numbers. Now we can use method of particular values for multinomial expressions also. Now one of the very common questions that we generally get in binomial as well as in multinomial expression is sum of all the coefficients. So if I have to find sum of all the coefficients, that is what I'm looking for is A0 plus A1 plus A2 plus A3 plus A40. So I need all these coefficients, but I don't want this x. So the best way to do it is I'll simply have to put x equals 1. So if I'll put x equals to 1, then what I'm left with is on the right hand side, I'll get A0 plus A1 plus A2 plus A40. And this value will be 1 plus 1 plus 2. So there'll be 4. So there'll be simply 4 to the power 20. Now in the same question, they may say find the sum of all the coefficients with alternate plus and minus sign. Suppose I need to find A0 minus A1 plus A2 minus A3, and in the same way I'll get plus a to the power 40. So now if I need alternate plus minus sign, then I need to put the value of x as simply minus 1. So all I need to do is I'll just have to put the value of x as minus 1. So if I put x as minus 1, I'll get 1 minus 1, 0. So I'll get this as 2. So there'll be 2 to the power 20, and there'll be A0 minus A1 plus A2 minus A3, and there'll be plus a to the power 40. Now the third question can be, so I'll get another result when I'll add the two series. So if I'll add the two series, then what I'll get is, so I'll get 2 times, A1 will cancel, A3 will cancel, I'll get A0 plus A2 plus A4 up to A40, and that value will be 4 to the power 20 plus 2 to the power 20. I'll divide by 2, so I'll get A0 plus A2 plus A4 plus A40, which is 4 to the power 20 plus 2 to the power 20 divided by 2. So this is all standard theory which we have done for binomial. Maybe if I'll subtract it also, so if I'll subtract the second series from the first one, then I'm left with this A1, A3. So then it'll be 2 times A1 plus A3, and then it'll be A39, and it'll be simply 4 to the power 20 minus 2 to the power 20. I'll divide by 2. So then I'll get another series which is A1 plus A3 and plus A39, which is 4 to the power 20 minus 2 to the power 20 divided by 2. So we can find sum of all the coefficients, sum of the coefficient with alternate plus minus sign, sum of alternate coefficients, either starting with the first term or even number of terms or odd number of terms. So we can do that. Now again in this question, if I need A0 minus A2 plus A4 minus A6 or A1 minus A3 plus A5 minus A7, so we are going to do it in a similar way that we have done in binomial. So all I need to do is, in this question, I'll simply have to put x as iota. So if I put x as iota, I'll get 1 plus iota plus 2 iota square to the power 20, and there'll be A0, A1 iota, A2 iota square, A3 iota cube, a to the power 4, iota to the power 4, and then a to the power 40, iota to the power 40. Now it is 1 plus iota, and then iota square is minus 1, so there'll be minus 2, so minus 2 to the power 20, and there'll be A0 plus A1 iota, iota square is minus 1, so minus A2 minus A3 iota plus A4. So if I'll separate real and imaginary part, I can write it as A0 minus A2 plus A4, and then if I take imaginary part, I'll write A1 minus A3 plus A5. So that is, I need to find out real and imaginary part from the left hand side, which is minus 1 plus iota to the power 20. Now if I look at this expression, minus 1 plus iota, so in this case, the value of r is under root 2. Basic angle is pi by 4. Now quadrant is x negative, y positive. So when x is negative and y is positive, it is second quadrant. And in second quadrant, its argument is pi minus alpha, which is pi minus pi by 4. So which is 3 pi by 4. So I can write it as root 2 cos 3 pi by 4 plus iota sine 3 pi by 4. So here my basic assumption is you have already studied complex numbers. So this is a naught minus a2 plus a4, and then iota will be a1 minus a3 plus a5. So here I'll write, so root 2 to the power 20 will be 2 to the power 10. I'll be cos 3 pi by 4 into 20, Binomial Theorem, iota sine 3 pi by 4 into 20, and this is a naught minus a2 plus a1. Now if I'll simplify it, I'll get 2 to the power 10, and this is cos, now 4, 5, so which will be 15 pi, and then iota sine, so there'll be 15 pi, and this is a naught minus a2 plus a4, and plus iota, it is a1 minus a3 plus a5. Now what is cos n pi? So cos odd multiple of pi is minus 1, so there'll be minus 2 to the power 10, and sine n pi is 0, so there'll be 0 into iota. So if I'll compare real and imaginary part, so the value of real part is minus 2 to the power 10, and the value of imaginary part is simply 0. Now we can also have another series where we need to put 1 omega and omega square, as we have done in binomial theorem questions. Now traditionally there have been questions in binomial as well as multinomial where we need to find sum of all the coefficients. So when I see any binomial or any multinomial term, so I can express it as factorial line a1, a2, ar, x1 to the power a1, x2 to the power a2, xr to the power ar, where sum of all these terms, it should be n, and each of the numbers should be either 0 or a positive integer. Now in this case, I need to find sum of all the coefficients. So that is, I'll just need to find the sum of all the coefficients, leaving behind all the variable values. So if I have to find sum of all the coefficient either in binomial or any general multinomial, all I need to do is I'll just need to put the value of all the variables as 1. So if I'll put the value of all the variables as 1, then all I'm left with is sum of coefficient. So in any equation, if you have to find sum of all the coefficient, simply put the values of variables as 1. Now say for example, now here the question is, if the sum of the coefficients in x plus y to the power n is 4096, then I need to find its greatest coefficient. So I have sum of all the coefficients, which is 4096, and I need to find its greatest coefficient. Now we know that in any multinomial or any binomial, if I have to find the sum of all the coefficient, all I need to do is I'll just need to put all the variables as 1. So in this case, what I'll do is I'll simply put x as 1, and I'll also put y as 1. So if I'll put x and y as 1, then sum of all the coefficients, so it'll be simply 2 to the power n, and they'll be equals to 4096. Now 4096 is 2 to the power 12. So in this case, the value of n is 12. So it is the binomial expansion of x plus y to the power 12. Now in this expansion, I need to find its greatest coefficient. Now we know that the coefficient of middle term is greatest. Now because it's an even number, so here the value of r will be 12 by 2, so there will be 6. So the greatest binomial coefficient in this case will simply be 12c6. Now in this question it says, if the sum of the coefficients in the expansion of alpha square x square minus 2 alpha x plus 1 to the power 51 vanishes, then find alpha. So basically we need to find the value of alpha, and it says that sum of all the coefficients in the expansion vanishes. That is, the sum of all the coefficients is simply 0. Now in this case, the only variable that I have here is x. So simply in order to find sum of the coefficient, I'll need to put x as 1. So if I'll put x as 1, I'll get sum of all the coefficients. So sum of all the coefficients is given by, so now if I'll put x as 1, I'll get alpha square minus 2 alpha plus 1 to the power 51, and this sum is equal to 0. So I'll simply write alpha minus 1 to the power 102 equals to 0. Then in that case, the value of alpha will simply be 1. Now for a plus b plus c plus d to the power 8, we need to find sum of all the coefficients. Now sum of all the coefficients is very simple. I'll have to take each variable, which is a, b, c, d, and I have to put it equals to 1. So if I'll put it equals to 1, then sum of all the coefficients will simply be 4 to the power 8. So that's a very simple question, right? Now my next question is, find the sum of all the coefficients that doesn't contain c. So I need to find sum of all the coefficients that doesn't have c. So previously we need to find all the coefficients, sum of all the coefficients, and that was simply 4 to the power 8. Now in this case, I need to have all those terms that doesn't contain c. So what I'll do is, so for all the terms that doesn't have c, I'll simply put c equals 0 because that will make all the terms containing c as 0. Now I need to find sum of all the coefficients. So in that case, I'll simply put a as 1, b as 1, and then d as 1. So in that case, sum of all the coefficients that doesn't contain c will simply be, so I'll put c0, a, b and d as 1. So in this case, answer will simply be 3 to the power 8. Now I'll come to the third question, which is, I need to find sum of all the terms, sum of all the coefficients that contains b but doesn't contain c. Now, how do I do that? So I need to find all those terms that doesn't contain c. So that's simple. So for that, I'll simply put c equals to 0. So if I'll put c equals to 0, I'll get all those terms that doesn't have c. But then I have to make sure that term should also have b. Now, how do we do that? So what I'll do is, I'll take all the terms, or I'll take sum of all the coefficient that doesn't contain c, that is total sum. And from this total sum, I'll subtract all those terms in which it doesn't have c and it also doesn't have b. So in this case, so for the first case, I'll put c as 0 and I'll put a, b and d as 1. So which will give me sum of all the coefficient that doesn't contain c. So it may have b, it may not have b. And from this, I'll remove all the coefficient or sum of all the coefficient that doesn't have b and c both. So in this case, I'll put a and d as 1 and I'll put c as 0 and d as 0. So here will be 3 to the power 8 and minus 2 to the power 8. So answer to this question will be 3 to the power 8 minus 2 to the power 8. Now there will be some questions in binomial series where we need to use simple algebra like addition of terms or subtraction of terms. So I'll take up an example. Say for example, the question is, we are given the expansion of x plus a to the power n and says sum of the odd terms is p and sum of even terms is q. Then I need to find the value of 4p into q. So what I know is, I can write this x plus a to the power n as simply p plus q. That is sum of odd terms plus sum of even terms. Now I'll also take x minus a to the power n. Now when I'll take x minus a to the power 10, I'll get the same terms but with alternate positive and negative signs. So odd number terms, that is first, third, fifth term, they'll be positive, and second, fourth and sixth term, they'll be negative. So I can write x minus a to the power n as p minus q. Now from the two given equation, I can find the value of p and q. So if I'll add them, I'll get 2p as x plus a to the power n and then x minus a to the power n. And if I'll subtract, I can write 2q as x plus a to the power n minus x minus a to the power n. Now I need 4pq. So what I'm going to do is, I'm simply going to multiply these two. So if I'll multiply these two, I'll get it as 4pq and then it is a plus b into a minus b, which is a square minus b square. So I'll write it as x plus a to the power 2n minus x minus a to the power 2n. So answer to this question simply will be x plus a to the power 2n minus x minus a to the power 2n. The question is, find the sum of coefficients of integral powers of x in the expansion of 1 minus 2 root x to the power 50. So what I'll do is, I'll write the binomial expansion of 1 minus 2 root x to the power 50. So it will be simply 50c0 minus 50c1 2 under root x plus 50c2 2 root x whole square, and will continue up to 50c50 and 2 root x to the power 50. Now in this series, I need the terms where the power of x is integral. So that is, I need first term, I need third term, fifth term, I need this term, and I don't need 50c1, I don't need 50c3 because they'll have square root or they'll have this irrational powers. So I need to find the sum of odd terms. And how do we find the sum of odd terms? I'll simply take its conjugate. So I'll write 1 plus 2 root x to the power 50, and there'll be 50c0 plus 50c1 2 root x, 50c2 2 root x square and then 50c50, 2 root x to the power 50. Now I need to cancel out these terms, so I'll add them up. So if I'll add them up, I'll write 1 minus 2 root x to the power 50 and plus 1 plus twice under root x to the power 50. So I'm left with this 2 50c0 plus 50c2 into 2 root x square, and then it'll be 50c50 and 2 root x to the power 50. So now I have this series where all the powers of x, they are integral. Now I do not want this series, I want sum of coefficients. And how do we get sum of coefficient? So in order to get sum of coefficient, all I need to do is, I'll just need to put the value of every variable as 1. So I'll put x as 1 in the series. So if I'll put 1 here, I'll get minus 1 to the power 50. And this is 1 plus 2 to the power 50. And this is, I'll take this 2 on the left hand side, divide by 2. And this is the sum of coefficients of integral power of x. So this sum will be 3 to the power 50 plus 1 divided by 2. So answer to this question simply will be 3 to the power 50 plus 1 divided by 2. So here also we'll just need to either add the two series or subtract the two given series. Question is, let 1 plus root 2 to the power n is equal to xn plus root 2 into yn, where xn and yn, they are integers. Then which of the following options is or are correct? Now what I know is 1 plus root 2 to the power n will be nc0, nc1 into root 2, nc2 into root 2 square, nc3 into root 2 cube, and then ncn into root 2 to the power n. Now if I look at these terms, nc0, nc2, nc4, they'll be the terms with integral powers. So that should be your xn, and this root 2, which is nc1, and then nc3 into root 2 cube. So all these terms, they'll be your yn. So if I have to write the expansion of 1 minus under root 2 to the power n, I'll simply know this expansion will be nc0 minus nc1 root 2 plus nc2 into root 2 square minus nc3 into root 2 cube and ncn and minus root 2 to the power n. So what I can do is, I can simply write this one as, so what's given? It's given that 1 plus root 2 to the power n is nothing but xn plus root 2 yn. And for the second one, 1 minus root 2 to the power n, I can write it as xn minus under root 2 yn. So the first thing that I'll do is, I'll multiply both of them. When I'll multiply both of them, on the right hand side, I'll get xn square minus y, a square minus b square. So there'll be 2 yn square, and here will be a square 1 minus 2 to the power n. So from here, I'll get my first result, and which is xn whole square minus twice yn whole square, and this value should be equals to minus 1 to the power n. So that is option number A is correct. So that means option number C will be incorrect. So we are discussing the result for all natural numbers n, or all integral values of n. Now what about these results, xn plus 1 and yn plus 1? So what I know is, if I have to write 1 plus root 2 to the power of n plus 1, I know it will be xn plus 1 plus root 2 yn plus 1. Now I can write 1 plus root 2 to the power n plus 1 as 1 plus root 2 into 1 plus root 2 to the power n, and this should be x to the power n, xn plus 1 and root 2 yn plus 1. So now I'll put this value, and this value is xn plus root 2 yn. So I'll write it as 1 plus root 2 will be xn plus root 2 yn, and this is xn plus 1 plus root 2 yn plus 1. Multiply them. So if I'll multiply them, then I can write it as, so I'll write it here, xn, and then root 2 and root 2 will be plus, so there'll be 2 times yn, and then plus, if I'll take the terms containing root 2, so there'll be root 2, and here will be xn plus yn. And this value, it should be equals to xn plus 1 plus root 2 y1. Now comparing rational and irrational parts. So if I'll compare the rational part, I'll get xn plus 1 as xn plus 2yn, and if I'll compare the irrational part, I'll get yn plus 1 as xn plus yn. So that is xn plus 2yn is xn plus 1, which is the option number B, and yn plus 1 is xn plus yn. So in this question, option number A, B and C, A, B and D, they are correct, and option number C is incorrect. The question is, find the degree of polynomial px, which is under root x to the power 5 minus 1 plus x to the power 7 and minus under root x to the power 5 minus 1 minus x. Now what I see here is, one of the expression is a plus b to the power n, and the other expression is a minus b to the power n. So when I say a plus b to the power n, I'll get nc0, a to the power n, nc1, a to the power n minus 1b, nc2, a to the power n minus 2 into b square. And for the second one, I'll get the same series, but with alternate plus and minus sign. So there'll be a n minus 1b, nc2, a to the power n minus 2b square. If I subtract the second series from the first series, I'm left with all even number terms, right? So in the given polynomial, I see it as a plus b to the power n and minus a minus b to the power n. So I need not write all the 8 terms. I'll just need to write 4 terms, and the terms containing nc1, nc3, nc5 and nc7. So I'll write it as, so px will be, so there'll be 2 times because they want to add up, and then first one will be 7c1 under root of x to the power 5 minus 1, so which is 6, and then x to the power 1 plus 7c3 under root of x to the power 5 minus 1, 7 minus 3, x to the power 3, 7c5 under root of x to the power 5 minus 1, 7 minus 5 x to the power 5, and plus 7c7, and this is x to the power 7. So if I'll simplify, I'll write it as 7c1, and here will be x to the power 5 minus 1, 6 by 2 will be 3 into x, 7c3, and there'll be 4 by 2 is 3, so there'll be x to the power 5 minus 1 whole square into x cube, 7c5, so it'll be simply x to the power 5 minus 1, x to the power 5, and then 7c7 into x to the power 7. Now I'm not interested in expressing it as a polynomial. All I'm interested in is to find the degree of this polynomial. So I need to find highest power of x. So from this expression, x to the power 5 minus 1 to the power 3, I'll get x to the power 15, and this x to the power 15 will get multiplied with this x. So the highest power of x in this case will be 16. So the degree of this polynomial will be 16. So let us take up a question, and the question is, find the value of root 3 plus root 2 plus 1 to the power 6 plus root 3 plus root 2 minus 1 to the power 6 plus root 3 minus root 2 plus 1 to the power 6 plus minus root 3 plus root 2 plus 1 to the power 6, and the fractional part of this entire value or number. So where these brackets, they represent fractional part function. Now we need to find the fractional part of this given number. Now what I'll do is, I'll write this as root 3 plus root 2 and then plus 1 to the power 6. And here I'll write root 3 plus root 2 minus 1 to the power 6. Here it is root 3 minus root 2 plus 1 to the power 6. And here I'll take minus 1 common. So minus 1 to the power 6 will be simply plus 1. So I'm going to write it as root 3 minus root 2 and minus 1 to the power 6. Now if I write the series summation for this one, so using binomial, so I'll consider this as A and this as B. So I can write the series as summation r varies from 0 to 6 NCR root 3 plus root 2 to the power 6 minus r, and then 1 to the power r will be same 1. So here r varies from 0 to 6, and here will be 6CR, it will be root 3 plus root 2 to the power 6 minus r, and then minus 1 to the power r. In the same way, I'll write it for this one. So it will be summation r varies from 0 to 6, 6CR root 3 minus root 2 to the power 6 minus r. And for this one, it will be summation r varies from 0 to 6, 6CR root 3 minus root 2 6 minus r, and then minus 1 to the power r. Now, if I look at these two terms, it is nothing but a plus b and a minus b. So what will happen is, when this r is an odd number, in that case, these two terms, they'll cancel. And when r is an even number, they'll add up, right? So what I'll do is, I'll write it as 2 times and summation. Now, r will take only even values. So r will be either 0, 2, 4, and 6. So I'll write it as 6 cr root 3 plus root 2 to the power 6 minus r. So when the value of r is odd, these terms, they'll cancel out. And when r is even, they're going to add up, right? In the same way, I can write it for second one also. There'll be 2 times and summation. Again, r will take even values 0, 2, 4, and 6. And here will be 6 cr root 3 minus root 2 to the power 6 minus r. Now I'll take the two summations together. So I'll write it as 2 times and then summation. R varies from 0 to 4 and 6. And I'll also take 6 cr common. Then I'll write it as root 3 plus root 2 to the power 6 minus r plus root 3 minus root 2 to the power 6 minus r. When r is even, then 6 minus r will also be even. And this again is of the form a plus b and a minus b. So in this case again, all the even number terms, they'll cancel. So here what I'll get is 2 times summation. R varies from 0 to 4 and 6. And it'll be 6 cr. And here I'll get 2 times. So I'll get this first term, which is 6 cr. 6 minus r c0. Root 3 to the power 6 minus r. Root 2 to the power 0. And then plus 6c2 root 3 to the power 6 minus r minus 2 root 2 square, and this series will continue. Now when I look at this series, root 3 to the power 6 minus r is an even number, so 6 minus r is even, 6 minus r minus 2 is even, root 2 to the power 0 is even, power 2 is even, power 4 is even. So every time when I'm getting a square root, I'm getting it with an even power. So when I'm getting square roots with even power, I know there'll be no irrational terms in this expression. All the terms, they'll be simply integral. So that is the value of this number, or this number is actually an integer. Now when this number is an integer, and if I have to take the fractional part of any integer, so fractional part of any integer is simply 0. So answer to this question is 0. Another powerful technique in binomial series is reversing technique. So what I'll do is, I'll take a summation and I'll write it as summation. R varies from 0 to n, fr. So if I'll put the value of r, I can write it as f0 plus f1 plus f2, and it'll continue up to fn. Now what I'll do is, in this series, I'll replace r with n minus r. So if I'll replace r with n minus r, I can write it as r varies from 0 to n and f n minus r. Now if I'll put r as 0, I'll get it as fn. If I'll put r as 1, I'll get it as fn minus 1. It'll be fn minus 2. And then if it is n minus 1, so n minus 1, it'll be f1. And then it'll be f0. So if I'll replace r with n minus r, I'll end up getting the same series. It is f0, f1, fn, and it is fn, fn minus 1, and f0. So it's just that the series is completely reversed. So we'll use this technique where we are going to replace r with n minus r to reverse the series, and then we are going to manipulate the two given series to work out binomial coefficient. Now this series is particularly useful because we know that in case of binomial coefficients, NCR is same as NC n minus r. So when I'm going to replace r with n minus r, I'll end up getting NCR again. And secondly, this series is of much use when I have binomial coefficients when they are multiplied with an arithmetic progression. So if there are questions where there are binomial coefficient and they are multiplied with numbers which are in arithmetic progression, then in that case, this reversing technique is the most wonderful or is the easiest choice to solve this binomial series. Now I'll take up an example. Say for example, suppose I'm given a question which is, find the sum of series 1 into NC0, 2 into NC1, 3 into NC2, and plus n plus 1 into NCN. So it is 1 into C0, 2 into C1, 3 into C2, and then n plus 1 Cn. We need to find the sum of this binomial series. Now what you know is these numbers 1, 2, 3 and n plus 1, these numbers, they are in arithmetic progression. So if they are in AP, then I may use reversing technique. So what I'll do is I'll take this sum. I'll say the sum of the series is simply S. Now I'll take the same series and I'll reverse it. So if I'll reverse it, I'll write n plus 1, and what I know is NCR is same as NCN minus R. So I'll write this NCN as NC0. Now the term before this one will be NCN minus 1. So here I'll write N, and then NCN minus 1 simply will be NC1. I'll continue. Now here I'll get this 2, and NC1 I can write it as NCN minus 1, and finally it will be 1, and then it will be NC0 is same as NCN. So what I've done is I've completely reversed the series, and at the same time I've changed the coefficient. So I'm going to write NCR as NCN minus R. Now I'll add the two series. So if I add the two series, I'll get this as 2S. Now here if I'll add these two terms, I'll get n plus 2. N plus 2 into C0. Here again I'll get n plus 2. C1. Here also I'll get n plus 2. Cn minus 1. And here also I'll get n plus 2. I'll be Cn. So what I'll do is I'll take this n plus 2 common. So I'll write 2S is equal to n plus 2, and then it'll be C0 plus C1 plus Cn. So I'll divide by 2. So this is S. This is n plus 2 by 2. And NC0 plus NC1 plus NCn is a standard series, right? So it is 2 to the power n. So answer to this question simply will be n plus 2 into 2 to the power n minus 1. So this is how we are going to use reversing technique. So we are simply going to reverse the series, and then at the same time I'll change the binomial coefficient. Now I can also solve this question using summation. So if I have to write this series, I can write this series as simply summation R varies from 0 to n, and then when the value of R is 0, it is plus 1. When the value of R is 1, it is 2. So I'll simply write R plus 1 NCR. Now I'll replace R with n minus R. So now if I'll replace R with n minus R, I can write it as summation R varies from 0 to n. Now in place of R, I'll write n minus R plus 1, and here I'll write NC n minus R. Now NC n minus R is same as NCR. So again I'll write it as summation R varies from 0 to n minus R plus 1 into NCR. Now I've got two series. So what I'll do is I'll add them up. So if I'll add the two series, then I'll get 2S, and then it will be summation R varies from 0 to n. Now NCR, it is common, so I'll take it common. And here I'll get R plus 1, and here I'll get n minus R plus 1. Now R and R it will cancel, so I'll get this as n plus 2. Now this summation is in terms of R, not in terms of n, so I'll take this n plus 2 out. So I'll write it as n plus 2 into summation R varies from 0 to n, and it is NCR. So this is 2S n plus 2, and summation of NCR is nothing but NC0 plus NC1 plus NCn, which is nothing but 2 to the power n. So I'll simply write it as S is n plus 2 into 2 to the power n minus 1. So either we can solve the question in expanded form, and we can also solve the question in summation form. Now the question is, find the sum of the series minus 1 NC0, 3 NC1, 7 NC2, 11 NC3, and then 4n minus 1 Cn. Now when I look at these numbers, minus 1, 3, 7, 11, I know it's an arithmetic progression with common difference of 4. So I know I have to use reversing technique. So I'll reverse the series. I'll write the series as, so here I'll write 4n minus 1, and then NCn is same as NC0. So I'll write NC0. Then it'll be 4n minus 5 NC1, and it'll continue, and here it'll be 3 times, and then NC1 is NCn minus 1, and finally it'll be minus 1, and then NCn. Now I'll add the given two series. So if I'll add them, I'll get 2s, and here I'll get 4n minus 2. If I'll add them, I'll get 4n minus 2. Here also I'll get 4n minus 2. Here again I'll get 4n minus 2. So I'll get this number 4n minus 2 multiplied with every term. So I'll take this 4n minus 2 common. So if I'll take 4n minus 2 common, I'm left with the series nc0 plus nc1 plus ncn, which is nothing but the sum of all binomial coefficients. And this is 2s and this is 4n minus 2. And the sum of the series is 2 to the power n. So now I'll divide by 2. So I'll write s as 2n minus 1 into 2 to the power n. Now here the question is, if summation r varies from 0 to n, 1 upon ncr is alpha. So this is 1 upon nc0 plus 1 upon nc1 plus 1 upon nc2 plus 1 upon ncn, and this value is equal to some number alpha. Then it says find beta, which is r upon ncr in terms of alpha. Now when I see this number r, I know when I put r as 0, I'll get 0. So 0, 1, 2, 3, 4, 5, 6, n. So it is nothing but an arithmetic progression with common difference 1. So I'm going to use reversing technique for summation. So what I'll do is I'll replace r with n minus r. So if I replace r with n minus r, I'll get summation. R varies from 0 to n. In place of r, I'll write n minus r, and here I'll write nc n minus r. Now nc n minus r is same as ncr. So I can write it as summation. R varies from 0 to n minus r upon ncr. Now I'm going to add these two series. So if I'll add them, I'll get 2 beta. I'll be summation. R varies from 0 to n. And then in the denominator, I'll have this ncr. And the numerator, I'll have r plus n minus r. R and r will cancel. Now this is n. So I can take it out from the summation. So I'll write 2 beta. And then I'll take n out. And then summation. R varies from 0 to n. 1 upon ncr. And this summation 1 upon ncr is nothing but alpha. So I'll write this 2 beta is equal to n into alpha. So the value of beta is n into alpha by 2. So answer to this question is n alpha by 2. Now here the question is, evaluate the sum. Summation k varies from 0 to n. nck sin kx and cos n minus kx. Now I do not see numbers in arithmetic progression, but what I do see is this is r and it is n minus r. And it is ncr and ncn minus r. So I may try using reversing technique. So what I'll do is I'll reverse the series. I'll simply substitute k with n minus k. So I can write this sum as summation k varies from 0 to n, and it is ncn minus k, and there'll be sin n minus k into x, and there'll be cos n minus k into x. So I can write it as summation k varies from 0 to n. Now ncn minus r is same as ncr, so it will be nck. Now this expression will be sin n minus kx, and here n and n will cancel, so I'll write cos kx. Now I'll add the given two series. So if I'll add them, then I can write 2s and it will be summation k varies from 0 to n. Now I'll take this nck common. Now what I'll get is sin kx into cos n minus kx plus cos kx into sin n minus kx, which is nothing but sin a cos b plus cos a sin b, and there will be sin a plus b. So I can write it as 2s equals summation. The value of k varies from 0 to n, nck, and it will be sin a plus b, which in this case is kx plus n minus kx. So kx and kx will cancel. So I'll write the series as 2s equals summation k varies from 0 to n, nck into sin nx. Now this summation is in terms of k. So basically sin nx is constant, so I'll take it out. So I'll write 2s as sin nx and will be summation k varies from 0 to n, nck. So this is 2s, it will be sin nx, and nck summation is nothing but nc0, nc1, ncn, which is 2 to the power n. So in this case, the value of this sum will be, so I'll divide by 2. So I'll get 2 to the power n minus 1 into sin nx. So we'll consider another question in reversing technique, and the question is summation k varies from 0 to 2n minus 1 to the power k, 2n ck whole square is a. And I need to express the second series, which is minus 1 to the power k minus 2n, 2n ck whole square in terms of a. Now, n here is 2n, and in place of r, we are using k. So if I replace k with 2n minus k, I think I'll get here k, and also NCR is same as NC n minus r. So I'll use reversing technique. So I'll say the series is suppose S. Now I'll reverse the series. So I'll replace k with 2n minus k. So I'll write it as summation k varies from 0 to 2n minus 1 to the power 2n minus k. Here will be 2n minus k minus 2n, and simply it will be 2n c 2n minus k whole square. Now 2n and 2n will cancel, so I'll simply write it as summation k varies from 0 to 2n, and it will be minus 1 to the power 2n minus k. I can write it as minus 1 to the power 2n into minus 1 to the power minus k, and minus 1 to the power 2n will be simply 1, and minus 1 to the power minus k will be same as minus 1 to the power k, because if k is odd, then it will be minus. If k is even, then it will be plus. So I'm going to replace it with minus 1 to the power k, and here I'll get minus k, and here NCR is same as NCN minus r. So I'll write 2nck whole square. Now I'll add the two series. So if I'll add the two series, I'll get 2s, and then summation k varies from 0 to 2n. I'll take this minus 1 to the power k common. I'll also take 2n ck whole square common. And then I'm left with, so here I'm having k minus 2n, and here I'll have minus k. So here k and k will cancel, and I can take this minus 2n common. So I'll write 2s, and it'll be minus 2n summation value of k varies from 0 to 2n minus 1 to the power k twice n ck whole square, and summation minus 1 to the power k 2n ck whole square is nothing but a. So from here I can write the value of 2s is equal to minus 2na. So the sum of this series is simply minus n into a. Now another very common method for binomial series is algebraic method. And in algebraic method, we try and express the series in terms of summation, and then we'll try and work out general term in such a way that we can somehow simplify the summation. I'll take up an example. Say for example, suppose the question is, I need to work out 1 into NC1 plus 2 into NC2, 3 into NC3, and it goes up to n into NCN. So I can express this series as summation r varies from 1 to n r into NCR. Now what I need to do is, somehow I need to change this r, and I need to express everything in terms of some other function of n minus 1 or n plus 1 or r minus 1 or r plus 1. So I have to express it in terms of some other NCR. Now in this method, what I need to do is, I need to change this term. I need to change it in terms of some binomial coefficient for which summation will be simple. So what I'll do is, I'll expand it. I'll write it as r from 1 to n r, and this is factorial n, factorial r, and factorial n minus r. Now I have a problem with this r. I do not want this r here, right? So what I can do is, I can cancel this r with r into factorial r minus 1. So r and r will cancel. So I can simply write it as summation r varies from 1 to n, and this is simply r factorial n. I'll write it as r into factorial r minus 1, and then n minus r. Now here this r and r will cancel. Now again I want to express it in terms of NCR. Now what I see here is r minus 1, and here it is n minus r. So I can express it as n minus 1 minus r minus 1. In that case 1 and 1 will cancel. So what I'll do is, I'll also express this n as summation r varies from 1 to n. I'll write n into factorial n minus 1, factorial r minus 1, and then n minus r. So now I can take this n out, because summation is in terms of r, not in terms of n. So I'll take this n out, and then I can write this summation as value of r varies from 1 to n, and this is nothing but n minus 1 c r minus 1. Now if I'll put the value of r, then this series is actually nothing but n minus 1 c0, n minus 1 c1, and plus n minus 1 cn minus 1, which is nothing but sum of all binomial coefficient of the series having n plus 1 index, right? So the sum of the series is simply 2 to the power n minus 1. So answer to this question will be n into 2 to the power n minus 1. Let us take up another question, and the question is 1 into 2 nc2, 2 into 3 into nc3, and then n minus 1 n into ncn. And I'll try and solve this question using algebraic method. So I can express it as summation. Now value of r, it varies from 2 and it goes up to n. So r varies from 2 to n. And then I'll simply write this as ncr. Now if it is 2, then it is 2 here. For 3 it will be 3. For n it will be n. So here it will be r and r minus 1. So I need to simplify this series, right? So I need to get rid of r minus 1 and r. So what I'll do is, I can write it as summation. R varies from 2 to n. R minus 1 r. I can write it as factorial n, factorial r, factorial n minus r. So from 2 to n, r minus 1 and r. Now in order to cancel this r minus 1 and r, I have to express this r as r into r minus 1 and then r minus 2 factorial, and then it will be n minus r. Now since here we have r minus 2, in the numerator I'll need n minus 2. So I'll also write n minus 1 and then factorial n minus 2. Now here r minus 1 and r will get cancelled. Now n minus 1, it is independent of r. I can take it out of the summation, right? So I can write it as n minus 1 summation. R varies from 2 to n, and here I'll get n minus 2 factorial upon r minus 2 factorial and then n minus r. So which is nothing but this is n minus 1 summation. R varies from 2 to n minus 2 c r minus 2. So which is n minus 1 and then n minus 2 c0, n minus 2 c1, and then n minus 2 c n minus 2, which is nothing but 2 to the power n minus 2. So answer to this question will be n minus 1, 2 to the power n minus 2. So let us take up another question, which is 1 square c1, 2 square c2, and n square cn. So again I can express it as summation. The value of r varies from 1 to n, and there will be r square into ncr. So again I'll expand ncr. So I'll write r varies from 1 to n, r square, factorial n, factorial r, and there will be factorial n minus r. So I'll cancel one of the r with factorial r. So I'll write r equals 1 to n will be r, factorial n, factorial r minus 1, and then n minus r. Now I need to cancel this r also. So I cannot cancel r in this form. So what I'll do is I'll write it as summation. R varies from 1 to n, and then r minus 1 plus 1, factorial n, r minus 1, and then n minus r. So I'll split the summation in two parts. So I'll write it as summation. R varies from 1 to n, r minus 1 factorial n, factorial r minus 1, n minus r, and then plus summation. R varies from 1 to n, factorial n. So this n gets multiplied with 1, and then r minus 1, and then it will be factorial n minus r. So here I'll cancel this r minus 1 with r minus 1 into factorial r minus 2. So I'll write it as summation. R varies from 1 to n, and here will be factorial n, factorial r minus 2, and then n minus r. Now here one more thing that I can do is I can change it from, rather than taking it from 1 to n, I can take it from 2 to n, because I know when r is 1, then 1 minus 1 will be 0. So the term containing the value of r equals to 1 will be 0. So I'll change the summation from 2 to n, and for the second one I'm going to write it as summation r varies from 1 to n, and it will be factorial n, r minus 1, and then n minus r. Now here I have r minus 2. So in the numerator I'll need n minus 2. So I'll write it as n minus 1 into factorial n minus 2. And here it is r minus 1. So I'll write it as n into factorial n minus 1. So I'll take this common. So I'll write n minus 1 summation r varies from 2 to n, and this will be n minus 2 c r minus 2, and plus here I can take n common, so I write summation r varies from 1 to n, and here will be n minus 1 c r minus 1. So now it is n minus 1, and it is nothing but n minus 2 c0, n minus 2 c1, and then n minus 2 c n minus 2, and for the second one I'll get n, it will be n minus 1 c0, n minus 1 c1, and n minus 1 c n minus 1. So this is n minus 1. Now sum of the series, it's a standard series which is 2 to the power n minus 2, and the sum of this series is 2 to the power n minus 1. So that is the answer to this question. So I can take n common and 2 to the power n minus 2 common. So if I'll take n into 2 to the power n minus 2 common, then I'll get n minus 1 and then plus 2. So it is n plus 1 into 2 to the power n minus 2. So we can solve these questions using algebraic method. Now the question is, we need to find the sum of this series, which is nc0 upon 1, nc1 upon 2, nc2 upon 3, and ncn upon n plus 1. So again I'll express it as summation. So I'll write it as summation. The value of r varies from 0 to n, and then it'll be ncr. So when it is 0 it is 1, for 1 it is 2, so then it'll be r plus 1. So I'm going to write it as summation r varies from 0 to n, factorial n, factorial r, and then factorial n minus r. Now I can write this r plus 1 into factorial r as factorial r plus 1. So I'll write it as summation r varies from 0 to n, and here it is factorial r plus 1, and this is n minus r, and it is factorial n. So now it is r plus 1 and it is still n minus r. So in the numerator also I'll need n plus 1. So what I'll do is I'll multiply and divide it with n plus 1. Now I can take this n plus 1 out. So I'll write 1 upon n plus 1, and then summation, value of r varies from 0 to n. So it'll be factorial n plus 1, factorial r plus 1, and then factorial n minus r, which is nothing but n plus 1 c r plus 1. So it is 1 upon n plus 1, and then summation, the value of r varies from 0 to n, it is n plus 1 c r plus 1. So if I'll expand the series, I can write as 1 upon n plus 1, and it'll be, if I'll put r as 0, I'll get n plus 1 c1, n plus 1 c2, and then n plus 1 c n plus 1. Now I have the series, but then n plus 1 c0 term is missing. So what I need to do is I'll add n plus 1 c0, and I'll also subtract n plus 1 c0. So I can write it as 1 upon n plus 1, and this is n c0 plus n cn, so which will be 2 to the power n. So in this case it will be 2 to the power of n plus 1, and then minus n plus 1 c0, which is 1. So answer to this series will be 2 to the power n plus 1 minus 1 upon n plus 1. So the question is nc0 upon 1 into 2, nc1 2 into 3, nc2 3 into 4, and ncn n plus 1 into n plus 2. So again I'll write it in summation form. So I'll write summation r varies from 0 to n, and then it'll be ncr upon, now here will be r plus 1 and r plus 2. So I'll write ncr as summation r varies from 0 to n, and here will be factorial n. Now this is r plus 1 r plus 2 into factorial r, and then factorial n minus r. So I can write factorial r into r plus 1 into r plus 2 as factorial r plus 2. So I'll write it as summation r varies from 0 to n, and this is factorial r plus 2, and then n minus r. So here we have changed it to r plus 2, and it is still n minus r. So I'll need n plus 2. So what I'll do is, in the numerator also, I'll multiply n plus 1, n plus 2, and I'll multiply and divide with. So in the denominator also, I'll multiply it with n plus 1 and n plus 2. So I'll take it out of the summation. So I'll write 1 upon n plus 1, n plus 2, and then summation. Value of r varies from 0 to n, and here it will be factorial n plus 2, factorial r plus 2, and then factorial n minus r, which is nothing but 1 upon n plus 1, n plus 2 into summation over all r varies from 0 to n will be n plus 2c r plus 2. Now I'll expand this series. If I'll expand the series, I can write it as 1 upon n plus 1, n plus 2, and then if I'll put r as 0, I'll get n plus 2 c2, n plus 2 c3, and continue up to n plus 2 c n plus 2. Now in this series, there are two terms which are missing, right? So I'll add them. So I'll add n plus 2 c0 and then n plus 2 c1. And because I've added them, I need to subtract them also. So I'll write minus n plus 2 c0 and minus n plus 2 c1. Now this series, it's a standard binomial coefficient series. So this one will be 1 upon n plus 1, n plus 2, and it will be 2 to the power n plus 2, and then nc0 is simply 1, and then minus nc1 is n, so it will be n plus 2. So answer to this question will be 2 to the power n plus 2 minus n minus 3 upon n plus 1 into n plus 2. So this method, we call it algebraic method. So let us take another question, which is nc1 upon 2, nc3 upon 4, nc5 upon 6. So I'll express it in terms of summation. So it will be summation over some r, where r starts from 1. And then here it is 1, 3, 5, which is odd numbers. So it is nc, I'll be 2r minus 1, 2r. So I'll write it as summation, r starts from 1, and then it will be factorial n, 2r, I'll be 2r minus 1 factorial, and then it will be n minus 2r, and then plus 1. So I'm going to write it as summation r starting from 1 and then factorial n, will be factorial 2r, and here will be n plus 1 minus 2r factorial. Now here we have 2r and here it is n plus 1 minus 2r. So I need n plus 1 in the numerator. So I'll multiply and divide it with n plus 1. So I'll take this n plus 1 out. So I'll write 1 upon n plus 1. And here I'll get summation r starts from 1 and it is factorial n plus 1 factorial 2r and then n plus 1 minus 2r, which is 1 upon n plus 1, and then summation r starts from 1 and will be n plus 1 c 2r. So if I'll express this summation, if I'll expand it, I'll get 1 upon n plus 1, and here will be n plus 1 c2, n plus 1 c4, n plus 1 c6. Now the first term is missing, so I'll add n plus 1 c0, and I'll also subtract n plus 1 c0. Now what is sum of all the coefficients containing even terms? So that is 1 upon n plus 1, and it is 2 to the power n minus 1. So n plus 1 minus 1 and then minus 1. So in this case, answer will be 2 to the power n minus 1 upon n plus 1. Now there will be questions in binomial series where we need to use differentiation. Now say for example, question is 1c1 plus 2c2 plus 3c3 plus ncn. Now we have already solved this question using reversing technique because the coefficients, they are in arithmetic progression. We have also solved this question using summation or algebraic method. Now we'll try and solve this question using differentiation. Now if I look at the expansion of 1 plus x to the power n, then what I know is it is c0, c1 into x, c2 into x square, cn into x to the power n. Now if I differentiate c0, there is no x. After differentiation, it will be 0. If I differentiate x, I'll get 1. If I differentiate x square, I'll get 2x. If I differentiate x cube, I'll get 3x square. And if I differentiate x to the power n, I'll get nxn minus 1. So these coefficients that I need, I can get it from powers of x. So what I'll do is, I'll simply differentiate it. And I'll differentiate it with respect to x. So if I'll differentiate, I'll get n 1 plus x to the power n minus 1. And that is summation. R varies from 0 to n. So it is ncr and then r into x to the power r minus 1. So I can either differentiate in the summation form or I can differentiate in the expanded form. So it will be 0, then c1 into 1, c2 into 2x, c3 into 3x square, and then plus cn into n into x to the power n minus 1. Now, what do I need? I need 1 into C1, 2 into C2, 3 into C3. So that is sum of the coefficient on the right hand side. So for sum of any coefficient, all I need to do is, I'll just need to put the value of x as 1. So if I'll put value of x as 1, I'll get it as n into 2 to the power n minus 1. And here will be 1 into C1, 2 into C2, plus 3 into C3, and then n into Cn. So answer to this series will be simply n into 2 to the power n minus 1. Now what if I need this series? 1 into C1 minus 2 into C2 plus 3 into C3 minus 4 into C4 and then minus 1 to the power n into Cn. Now in this case is the same series 1, 2, 3, 4 but then with alternate plus and minus sign. So what I'll do is again in this I'll put x as minus 1. So if I'll put x as minus 1, 1 minus 1 will be 0 and here I'll get 1 into C1 and then if I put x as minus 1 I'll get minus 2 into C2. Again minus 1 square will be plus, so it will be 3C3 and will continue up to NCN and then minus 1 to the power n minus 1. So answer to this series will be simply 0. Now another question in this could be, suppose I need to find 1 into 2C2, 2 into 3C3, 3 into 4C4 and then n minus 1 into n into Cn. So I need to find the sum of this series. Now here we have two numbers 1 and 2, 2 and 3, 3 and 4, n minus 1 and n. Now what I know is when I've differentiated it once, I've got this 1. Now it is 2, it is 3 and this is n. Now here I don't want this term. So if I'll differentiate it again, I'll get this as 0. If I'll differentiate, I'll get 1 into 2. If I'll differentiate it, I'll get 3 and then into 2x. And here I'll get n into n minus 1. So what I'll do is, I've already differentiated it once. So I'm going to differentiate it again. So if I'll differentiate it one more time, then I'll get n minus 1, 1 plus x to the power n minus 2. And here I'll get, so these two terms, they'll be 0. And here I'll get C2, 2 into 1, C3, 3 into 2x, C4, 4 into 3x square. And here in the end I'll get Cn, n minus 1 into x to the power n minus 2. Now I need the sum of this series, right? So I need the sum of coefficients. So again I'll put x as 1. So if I'll put x as 1, I'll get this series as n minus 1, 2 to the power n minus 2. And this result will be 1 into 2 C2, 2 into 3 C3 and then n minus 1 into n into Cn. So answer to this series will be simply n minus 1, 2 to the power n minus 2. Now suppose the question is 1 square into C1, 2 square into C2, 3 square into C3 and n square into Cn. Now in this case, again I'll take the same series 1 plus x to the power n and again I'll differentiate it. So if I'll differentiate, I'll get n 1 plus x to the power n minus 1, which is 1c1, 2c2, 3c3 and ncn. So I've got this 1c1, 2c2, 3c3, 4c4 and ncn. But if I differentiate it again, I'll get 2 into 1, I'll get 3 into 2. So what I need is, I need 1 here again, I need 2 here again, I need 3 here again. So first what I'll do is, I'll multiply the series with x. So if I'll multiply it with x, I'll write nx and then 1 plus x to the power n minus 1. And here will be c1x, c2 into 2x square, c3 into 3x cube, and then it will be ncn into x to the power n. So when I've multiplied it with x, the powers are restored. So if I'm going to differentiate it again, I'll get 1 again, I'll get 2 again, I'll get 3 again. So now I'll differentiate it again. Now since it's a product of two functions, I need to use product rule. So it will be nx, and if I'll differentiate this one, I'll get n minus 1, 1 plus x to the power n minus 2, and then plus 1 plus x to the power n minus 1 as it is, and then derivative of nx is simply n. And here I'll get c1, this is 1, c2, it will be 2x, c3 into 3, and there will be 3x square, and then finally it will be ncn and nx n minus 1. So here we have 1 square, 2 square, 3 square, n square. Now I need just the sum of coefficient. I do not want this variable. Again, I'll put x as 1. So if I'll put x as 1, I'll get it as n minus 1, 2 to the power of n minus 2. And here will be 2 to the power of n minus 1 into n. And here will be 1 square into c1, 2 square into c2, 3 square into c3, and then plus n square into cn. So here I can take n and 2 to the power n minus 2 common. So if I'll take 2 to the power n minus 2 into n common, so I'll get n minus 1 plus 2, so which is n 2 to the power of n minus 2 into n plus 1. So answer to this series will be n plus 1, 2 to the power of n minus 2. Now the question is, let S1 is j minus 1 10 cj, S2 is j into 10 minus j, and S3 is j square into 10 minus j. We need to find the value of S1, S2 and S3. So what I know is the value of n here is 10. So I'll simply write 1 plus x to the power 10. It is summation. J varies from 0 to n or 0 to 10, and then ncj into x to the power j. So I have written general term ncr into x to the power r. Now for this S2, I'll need this j. So I'll differentiate it once. So if I'll differentiate it once, I'll get 10, 1 plus x to the power 9. It'll be summation. J varies from 0 to 10. And there'll be ncj into j into x to the power j minus 1. Now I need j into ncj, not x. So simply what I'll do is, I'll put the value of x as 1. So if I'll put value of x as 1, I'll get it as 10 into 2 to the power 9. And here will be summation. J varies from 0 to 10. Will be ncj into j. Now when j is 0, the term is 0. So I can actually write this summation as summation. J varies from 1 to 10. Will be j into ncj, which is 10 cj. So that's your S1. So that's your S2. So the value of S2 is 10 into 2 to the power 9. Now I need j minus 1. So what I'll do is, I'll differentiate it one more time. So if I'll differentiate it one more time, I'll get 10 into 9. And then 1 plus x to the power 8. Here will be summation. J varies from, now I won't take 0 because for j equals to 0, the term is 0, right? So I'll start with 1, from 1 to 10. And here will be ncj and then j. If I'll differentiate it again, I'll get j minus 1 into x to the power j minus 2. Or here the value of n is simply 10. Now again, I need 10 cj, j into j minus 1. I don't need this x, so I need the sum of coefficient. So I'll put x as 1 again. So if I'll put x as 1, I'll get 90 into 2 to the power 8. And here I'll get summation. J varies from 1 to 10. 10 cj, j into j minus 1, and which is nothing but S1. So the value of S1 is 90 into 2 to the power 8. Now I'll come to this S3. So again, I'll start from here. So I'll write 10, 1 plus x to the power 9. It is summation. J varies from, I'll start with 1. So j varies from 1 to n, 1 to 10, and then 10 cj into j into x to the power j minus 1. Now here I need j square. So for that, I need this power to be j. So I'll multiply it with x. So if I'll multiply it with x, I'll write 10x 1 plus x to the power 9 summation. J varies from 1 to 10. 10 c j into j, and then it'll be x to the power j. Now I'll differentiate it again. So if I'll differentiate it one more time, so I'll get 10x and then 9, 1 plus x to the power 8, then 1 plus x to the power 9 into 10, and here I'll get value of j varies from 1 to 10, 10 cj, here will be j square and x to the power j minus 1. I need the sum of coefficient. Again, I'll put x as 1. So if I'll put x as 1, I'll get it as 90 into 2 to the power 8, 10 into 2 to the power 9, and this is summation j varies from 1 to 10, 10 cj into j square, which is nothing but s3. So the value of s3 will be, I'll take this 10 into 2 to the power 8 common. So if I'll take 10 into 2 to the power 8 common, I'll get 9 plus 2. So there'll be 110 into 2 to the power 8. So the value of s2 is 10 into 2 to the power 9. The value of s1 is 90 into 2 to the power 8. And value of s3 is 110 into 2 to the power 8. Now there may be some questions in binomial series where we need to use partial derivatives. Say for example in this question where it is given that x plus y is 1, then we need to find summation r varies from 0 to n, r into ncr, x to the power r n, y to the power n minus r. Now when I see this ncr, x to the power r and y to the power n minus r, I know I can write it as expansion of y plus x to the power n. Now expansion of y plus x to the power n will simply be summation r varies from 0 to n, and then it will be ncr y to the power n minus r into x to the power r. Now I have this term ncr x to the power r y to the power n minus r. Now I need this r also. So where do I get this r? Now I see this r as an index of x or as an exponent of x, right? So if I differentiate it partially with respect to x, then I'll get it as r into x to the power r minus 1. So what I'll do is I'll differentiate this expression partially with respect to x. So I'll write n and then y plus x to the power n minus 1, and this summation value of r varies from 0 to n. So it'll be ncr y to the power n minus r, and it'll be r into x to the power r minus 1. Now it is given that x plus y is simply 1, so I'll put value of x and y here. So here will be n, and here I'll get summation r varies from 0 to n, r into ncr y to the power n minus r into x to the power r minus 1. Now here I need x to the power r, so what I'll do is I'll multiply x both sides. Summation is in terms of r, it's not in terms of x, so I can multiply x, right? So it'll be n into x is equal to summation r varies from 0 to n, and then r ncr y to the power n minus r into x to the power r. So answer to this summation simply will be n into x. So in this question we have used partial derivative. Now there will be questions in binomial series where we need to use integration also. Say for example question is c1 upon c0 upon 1, c1 upon 2, c3 upon 3 and cn upon n plus 1. So what I know is if I write the expansion of 1 plus x to the power n, then I'll get c0 c1x c2x square and then cn and x to the power n. Now in this case, if I integrate c0, then I'll get c0 into x. If I'll integrate this one, c1 into x square by 2. So I'll get c1 by 2 into x square. If I'll integrate x square, I'll get x cube by 3. If I integrate x to the power n, I'll get x to the power n plus 1 upon n plus 1. So the coefficient that I'll need in the denominator, I'll get it from integration. So what I'll do is I'll integrate both left hand side and right hand side. So I'll write integral of 1 plus x to the power n into dx. It will be integral of c0 dx, integral of c1x dx, integral of c2x square dx, and then integral of cn x to the power n into dx. Now there are two ways. Either I can use indefinite integral, then I have to use plus c, or I can put the limits. So I'll start with 0, and then for the upper limit, I just need coefficient, sum of the coefficient, not x. So for x, I need to put the value as 1. So I'll integrate it from 0 to 1. So if I integrate this left hand side, I'll get 1 plus x to the power n plus 1 upon n plus 1. Starting from 0 to 1, it will be c0x from 0 to 1, c1x square upon 2, 0 to 1, c2x cube upon 3, 0 to 1, and then cn x to the power n plus 1 upon n plus 1 from 0 to 1. So if I'll put the limit, so if I'll put upper limit, I'll get 2 to the power n plus 1, and then if I'll put lower limit, I'll get 1. So it'll be 2 to the power n plus 1 minus 1 upon n plus 1. So here I'll get C0 into 1. Here I'll get C1 upon 2 into 1. C2 upon 3 into 1. And then Cn upon n plus 1. So answer to this series is simply 2 to the power n plus 1 minus 1 upon n plus 1. Now I need to find some of this series, which is C0 upon 1 into 2, C1 upon 2 into 3, Cn upon n plus 1 into n plus 2. Now as the coefficients are in the denominator, I know I need to integrate, right? So I'll start with the basic series, which is 1 plus x to the power n, and this time I'm going to write it in summation form. So value of r varies from 0 to n. I'll be ncr and there'll be x to the power r. Now I'll integrate left hand side and right hand side. So if I'll integrate it, I'll get integral of 1 plus x to the power n into dx, and then it'll be integral of r varies from 0 to n, and then integral ncr into x to the power r into dr. Now I'll take lower limit as 0, and I'll still need upper limit to be variable. So I'll choose some variable. Maybe I'll say it is some variable, maybe y. So I'll write it as 1 plus x to the power n plus 1 upon n plus 1 from 0 to y. It'll be summation r varies from 0 to n, and there'll be ncr x to the power r plus 1 upon r plus 1, and then again from 0 to y. So on the left hand side, I'll get 1 plus y to the power n plus 1, and then minus 1 upon n plus 1. And on the right hand side, I'll get this series, which is summation r varies from 0 to n, and there'll be ncr y to the power r plus 1 upon r plus 1. So now I have r plus 1. Now I need r plus 2 also. So I need to integrate it again. So I'll integrate it again. So I'll write integral of 1 plus y to the power n plus 1 minus 1 into dy upon n plus 1. And here I'll write summation r varies from 0 to n and integral of ncr y to the power r plus 1 upon r plus 1 into dy, and I'll take my limits from 0 to 1, because here I need some of the coefficients. So I'll take the limits from 0 to 1. So if I'll integrate it here, so I'll take this 1 upon n plus 1 out, and then I'll have this integral, which is from 0 to 1 plus y to the power n plus 1 into dy, and then I'll have also this minus 1 upon n plus 1 integral of 0 to 1 into dy, and on the right hand side I'll write this as summation r varies from 0 to n, and here will be ncr upon r plus 1, and then integral of y to the power r plus 1 into dy from 0 to 1. So now I'll start integrating. So here I'll get 1 upon n plus 1, and here will be 1 plus y to the power n plus 2 upon n plus 2 from 0 to 1, and then minus 1 upon n plus 1 into y from 0 to 1, and here will be ncr upon r plus 1 y to the power r plus 2 upon r plus 2 summation from 0 to 1. So if I'll put the value, I'll get it as 1 upon n plus 1 n plus 2. So if I'll put upper limit, I'll get 2 to the power n plus 2, and then minus 1, and here I'll get minus 1 upon n plus 1, and here I'll get summation r varies from 0 to n ncr upon r plus 1 into r plus 2, which is the series that I'll need. So C0, 1, 2, C1, 2, 3, and Cn, n plus 1 and n plus 2. So answer to this series is this expression. So I'll simplify it also. So I'll take n plus 1 and n plus 2 common. So I can write it as 2 to the power n plus 2 minus 1, and then minus n minus 2. So it will be 2 to the power of n plus 2 minus n minus 3 upon n plus 1 into n plus 2. So the result of this series is 2 to the power n plus 2 minus n minus 3 upon n plus 1 into n plus 2. So the question is, prove that sum to n plus 1 terms of c0 upon n plus 1 minus c1 n plus 1 n plus 2 plus c2 n plus 2 n plus 3 is equal to this integral which is from 0 to 1 x to the power n minus 1 1 minus x to the power n plus 1 dx, and then we'll have to find this integral also. So now what I'll do is I'll write it as c0 and 1 upon n and 1 upon n plus 1. I'll write it as 1 upon n minus 1 upon n plus 1 because the common difference here is 1. In the same way, I'll write c1 and it'll be 1 upon n plus 1 minus 1 upon n plus 2. For c2, it'll be 1 upon n plus 2 and minus 1 upon n plus 3, and this series will continue up to n plus 1 terms. So I'll take this first series separately. So I'll write c0 upon n minus c1 upon n plus 1 plus c2 upon n plus 2, and then I'll write the second series as minus c0 upon n plus 1 minus c1 upon n plus 2, and then plus c2 upon n plus 3. So I'll write two separate series. Now for this series, I'll take 1 minus x to the power n. So I'll write it as c0 minus c1x plus c2x square minus c3x cube. Now here I'll need c0 upon n. So here the power of x should be n minus 1. So what I'll do is I'll multiply x to the power n minus 1. So if I'll multiply x to the power n minus 1, I'll write x to the power n minus 1, 1 minus x to the power n will be c0, x to the power n minus 1, c1 x to the power n, c2 x to the power n plus 1. Now I'll integrate. So if I'll integrate from 0 to 1, I'll get x to the power n minus 1, 1 minus x to the power n into dx. And if I'll integrate this one, I'll get x to the power n upon n. And if I'll put x as 1, I'll get it as c0 upon n minus c1 upon n plus 1 plus c2 upon n plus 2, which is my first series. Now for the second series, I'll write again 1 minus x to the power n, so which will be c0 minus c1x plus c2x square. Now here I need n plus 1, so I'll multiply it with x to the power n. So if I'll multiply it with x to the power n, I'll write 1 minus x to the power n, c0 x to the power n, c1 x to the power n plus 1, c2 x to the power n plus 2. So now again I'll integrate. So if I'll integrate, I'll write from 0 to 1 x to the power n 1 minus x to the power n into dx. And here if I'll integrate from 0 to 1, so it'll be x to the power n plus 1 upon n plus 1, and from 0 to 1 it'll be simply 1. So I'll write c0 upon n plus 1 minus c1 upon n plus 2 plus c2 upon n plus 3. So I've got the result for two separate series. Now in order to find the value of this expression, I can write it as first integral, which is from 0 to 1 x to the power n minus 1, 1 minus x to the power n dx, and then minus second integral, which is from 0 to 1 x to the power n and 1 minus x to the power n into dx. Now since the limit is same, so I'll combine it. So I'll write from 0 to 1 and I'll take 1 minus x to the power n common. And then what I'm left with is x to the power n minus 1 minus x to the power n into dx. Now here I can take x to the power n minus 1 also common. So if I take it common, I'll write from 0 to 1, 1 minus x to the power n, and here I'll get x to the power n minus 1, and here I'll get 1 minus x into dx. Now 1 minus x into n into 1 minus x simply will be 1 minus x to the power n plus 1. So I can write this integral as, or I can write this series as from 0 to 1, and then it'll be x to the power n minus 1 into 1 minus x to the power n and plus 1 into dx. So answer to this series will be this integral, which is from 0 to 1 x to the power n minus 1, 1 minus x to the power n plus 1. That was my first part. So 0 to 1 x to the power n minus 1, 1 minus x to the power n plus 1. Now the second part, we'll also need to evaluate this integral. Now let this integral be I. And I know I have to solve it by parts, but then I'll use the property first. From 0 to a fx is from 0 to a f a minus x. So in place of x, I'll write 1 minus x. So I'll write this integral as from 0 to 1 minus x to the power n minus 1, and then into 1 minus x, it'll be simply x, and that is x to the power n plus 1 into dx. Now I'll try and solve this question using by parts. So I'll take it as first function and I'll take it as second function. So if I'll use by parts, I'll write this integral as, now first function as it is, so it is 1 minus x to the power n minus 1. Now integral of x to the power n plus 1, so it will be x to the power n plus 2 upon n plus 2, limits from 0 to 1, and then minus from 0 to 1. Now I'll differentiate this one, so I'll get n minus 1, 1 minus x to the power n minus 2. Now derivative of minus x will be minus 1, and then integral of this function, which is x to the power n plus 2 upon n plus 2 into dx. Now when I put x as 1, so this 1 minus 1 will be 0. And for the second part, when I put x as 0, so this term will be 0. So the value of this first expression will be 0 till the value of n is 1 or greater than 1. So I'll write it as I. Now here minus and minus will be plus. So n minus 1 and n plus 2, they are constant. So I'll take it out. I'll write n minus 1 upon n plus 2. And I'll get this integral as from 0 to 1 minus x to the power n minus 2 and x to the power of n plus 2 into dx. So which is a similar form to the first one, right? So the first one was 1 minus x to the power n minus 1 and n plus 1. Here this power, it has decreased by 1, and here this power, it has increased by 1. So if I'll use by parts again, I'll again get the same result. So what I'll do is I'll use iteration. So this is n minus 1, n plus 2. Next one will be n minus 2, and then n plus 3, n minus 3, n plus 4, and finally in the end, I'll get this series as from 0 to 1. So there'll be this time when this 1 minus x to the power n plus 2, the power will be 0, so it'll be 1. Now this power will be 0 when it is n minus n. So in that case, it'll be n plus n. So then it'll be 1 into x to the power 2n into dx. So this series will continue, so which is n minus 1, n plus 2, n minus 2, n plus 3, n minus 3, n plus 4, and will continue up to, so here it will be x to the power 2n plus 1, which will be 1, and then upon 2n plus 1. So this is 1 into 2 into 3 up to n minus 1, so I can write it as factorial n minus 1, and here if I'll multiply it with, so this is n plus 2, n plus 3 up to 2n plus 1. So what I'll do is I'll multiply and divide it with factorial n plus 1. So now it'll be factorial 2n. Today we'll discuss a very cool question in binomial theorem, and the question goes like 1 into c1 minus 1 plus 1 by 2 c2 plus 1 plus 1 by 2 plus 1 by 3 c3, and it goes all the way up to minus 1 to the power n minus 1, 1 plus 1 by 2 plus 1 by 3 to 1 by n cn, and we need to prove that the sum of this series is simply 1 by n. Now what I'll do is I'll rearrange the series. I'll take up all the terms which are multiplied with 1. So I'll take all these terms. So if I'll take all these terms, I can write it as c1 minus c2 plus c3, and then the last one will be minus 1 to the power n minus 1 into cn. So this is the coefficient of 1, and then I'll take the second series, which is the coefficient of 1 by 2. So I'll have minus c2 plus c3, and again it'll go all the way up to minus 1 to the power n minus 1 into 1 by 2, and this is how this series it'll continue, and finally I'll have this term which is with 1 by n, and that term will be minus 1 to the power n minus 1 cn into 1 by n. So what I've done is I've rearranged the series as coefficients of 1, 1 by 2, 1 by 3 and 1 by n. So now what I'll try and do is I'll try and write this series as sum a1 into 1 plus a2 into 1 by 2 plus a3 into 1 by 3 and then plus an into 1 by n, and I want to express this a1, a2, a3 in sort of some general formula. So what I'll do is I'll take up any rth term, and for rth term the first thing that we need to decide is whether this series will start with a positive term or with a negative term. So clearly if it is first term then it is positive, second term negative, third term positive, fourth term negative. So that is when the value of r is odd, it starts with a positive term, and if the series is if the value of r is even, then the series starts with a negative term. So I can write it as minus 1 to the power r minus 1, and then now for the first term starts with c1, for the second term it starts with c2, and for the nth term starts with cn. So this series will start with cr, and then with alternate plus and minus, these coefficients they'll increase, and then finally it will be, now here will be minus 1. Now I know that this number is minus 1 to the power n minus 1, but I have already taken this minus 1 to the power r minus 1 out. So that means minus 1 to the power n minus 1 minus r plus 1. So that should be minus 1 to the power n minus r. So I'll write minus 1 to the power n minus r into Cn. So that should be the coefficient of 1 by r. So this is how, so I can write the series as summation ar into 1 by r, where the value of r varies from 1 to n. Now what I'll also do is I'll change these NCRs into NCn minus r. So I can write it as ar, and this is minus 1 to the power r minus 1, and this is n minus r. This is n minus r minus 1, and here will be minus 1 to the power n minus r, and here will be c0. So what I'll do is I'll reverse the series and I'll take minus 1 to the power n minus r common. So if I take it common, so I'll write minus 1 to the power r minus 1 minus 1 to the power n minus r. So I can write it as c0 minus c1 plus c2, and then finally I can write it here minus 1 to the power n minus r into c n minus r. Now here minus 1 to the power r minus 1 and minus 1 to the power n minus r, I can simply write it as minus 1 to the power n minus 1 c0 minus c1 plus c2, and it goes up to minus 1 to the power n minus r and c n minus r. Now what I'll do is I'll let this n minus r as some number k. So basically what I want to do is I need to find the sum of this series, which is c0 minus c1 plus c2 minus c3, and you go all the way up to minus 1 to the power k into nck. Now how do I find the sum of this series? So what I'll do is I can find the sum when I'm going to multiply 1 minus x to the power n with 1 plus x square x to the power k. So I'll take an infinite geometric progression. So 1x x square, it goes all the way up to infinite. So I can write it as c0 minus c1x plus c2x square minus c3x cube, and then 1 plus x square x to the power k. Now sum of an infinite GP, it is a upon 1 minus r. So I can write it as 1 minus x to the power n into 1 upon 1 minus x. And here on the right hand side, if I look at coefficient of x to the power k, so when do I get this coefficient of x to the power k? When this x to the power k gets multiplied with c0, when x to the power k minus 1 gets multiplied with c1, x to the power k minus 2 gets multiplied with c2, and when this 1 gets multiplied with x to the power k. So here on the right hand side, I can express it as c0 minus c1 plus c2, and then minus 1 to the power k ck, it is nothing but coefficient of x to the power k. So here I can write it as 1 minus x to the power n minus 1, and here will be c0 minus c1 plus c2 minus 1 to the power k ck, and it is x to the power k. So basically this series is nothing but coefficient of x to the power k in this expansion. So from this expansion, I have to find coefficient of x to the power k. Now in the expansion of 1 minus x to the power n minus 1, coefficient of x to the power k, it is given by n minus 1 ck and then minus 1 to the power k. So in this case, coefficient of x to the power k, we can find from its general term, and which is n minus 1 ck minus 1 to the power k. So this series, which is c0 minus c1 plus c2 minus c3 minus 1 to the power k ck, is nothing but n minus 1 ck and minus 1 to the power k. So it will be n minus 1 ck and minus 1 to the power k. So basically I can write this AR as minus 1 to the power n minus 1, and then it will be n minus 1 ck and minus 1 to the power k, and we have taken k as n minus r. So I'll actually write it as minus 1 to the power n minus 1, n minus 1 c, n minus r, and minus 1 to the power n minus r. So I'll take this minus 1 together. So I can write it as AR minus 1 to the power 2n minus r plus 1, and that should be n minus 1 c n minus r. So minus 1 to the power 2n, so minus 1 square will be a positive number, and there will be minus 1 to the power minus r plus 1. So when r is even, this number will be minus, and when r is odd, this number will be plus. So another way of writing this can be, I can write it as minus 1 to the power r minus 1 n minus 1 c n minus r. So this general coefficient in my series, I can write it as minus 1 to the power r minus 1 n minus 1 c n minus r. So now I can write this series as summation r varies from 1 to n, and AR, which in this case is minus 1 to the power r minus 1 n minus 1 c n minus r, and into 1 upon r. Now what I'll also do is I can write NCR as NCn minus r. So I will actually express it as summation r varies from 1 to n, and here will be minus 1 to the power r minus 1 n minus 1 and c. So n minus r will be r minus 1, and here will be 1 by r. So now if I'll expand the series, I can write it as, so when r is 1, I'll write n minus 1 c0 into 1, then minus n minus 1 c1, and will be 1 by 2, plus n minus 1 c2 1 by 3, and will continue up to minus 1 to the power n minus 1 n minus 1 c n minus 1 into 1 by n. Now I need to find the sum of the series. Now what I know is these coefficients 1, 1 by 2, 1 by 3, 1 by n, they appear when we do binomial summation using integration. So what I'll do is I'll take up the series 1 minus x to the power n minus 1. So I can write n minus 1 c0, n minus 1 c1x, n minus 1 c2x square, and then minus 1 to the power n minus 1, n minus 1 c n minus 1 into x to the power n minus 1, and I'll integrate this series from 0 to 1. So if I'll integrate this series, I'll get 1 minus x to the power n upon n, and coefficient of x is minus 1, so I'll get this minus sign, and it will be from 0 to 1. Here it will be n minus 1 c0, and then x from 0 to 1, minus n minus 1 c1, x square upon 2 from 0 to 1, n minus 1 c2, x cube upon 3 from 0 to 1, and then finally it will be minus 1 to the power n minus 1, n minus 1 c n minus 1, x to the power n upon n from 0 to 1. So if I'll put the value of x as 1, so it will be 0. If I'll put x as 0, it will be 1 by n. So on the left hand side, I'll get this value as 1 by n, and here I'll get n minus 1 c0, n minus 1 c1 into 1 by 2, n minus 1 c2 into 1 by 3, and then it will be minus 1 to the power n minus 1, n minus 1 c n minus 1 into 1 by n, which is the series that I'm looking for. So sum of this series is equal to 1 by n. So answer to this question, 1 C1, 1 plus 1 by 2 C2, 1 plus 1 by 2 plus 1 by 3 C3. So answer to this question is simply 1 by n. One of the most important and most beautiful series in binomial is when we have product of binomial coefficient. Now say for example, this question which is C0 CR, C1 CR plus 1 and Cn minus R into Cn. Now there are two possibilities. Possibility one is when the difference of the lower suffix of binomial coefficients, it is constant. Now when I look at this series, so what is the difference of suffix here? R minus 0, which is R plus 1 minus 1, it is again R plus 2 minus 2, again R, n minus R, again R. So in each of the term, the difference between the two suffix is R. So in these questions, what we generally do is we start with one of the series as 1 plus x to the power n. So I'll write nc0 plus nc1 x, nc2 x square, and because I need ncr plus 1, so I'll write ncr x to the power r, ncr plus 1, x to the power r plus 1, and continue up to ncn and x to the power n. Now I'll write the same series, but I'll write it in reverse. So I'll take the series which is x plus 1 to the power n. So here will be nc0 x to the power n, nc1 x to the power n minus 1, nc2 x to the power n minus 2, and this series will again continue up to ncn into x to the power 0. Now I need product of binomial coefficient. So that simply means I have to multiply these two series. So when I'll multiply these two series, so here it is 1 plus x to the power n, here also it is 1 plus x to the power n. So on the left hand side I'll get 1 plus x to the power 2n, and on the right hand side I'll have many terms. So it'll be nc0 square, nc0 into nc1, nc0 nc2, nc0 ncn, and then each of the term will get multiplied with every other term. Now on the right hand side, I won't look for all the products. So on the right hand side, what I look for is, I look for the coefficient of x or the power of x, from where I'll get this product, which is C0 into CR. So I'll get this C0 into CR when I'll multiply this C0 with this NCR. So in this case, it'll be NC0 into NCR, and there'll be x to the power n plus r. Next one is C1 into CR plus 1. So then I need to multiply NC1 with NCR plus 1. So in this case, it is x to the power r plus 1, and here will be x to the power n minus 1. So again, I'll get x to the power n plus r. And finally, I need to write this term. So I'll write C n minus r, C n minus r, x to the power r. So now, finally, I'll need to multiply Cn minus r with Cn. So again, this series is x to the power n plus r. So there are many terms on the right hand side. But if I look at this series, then this series, it comes up with the coefficient of x to the power n plus r. So if I'll multiply them, I can simply write, so there will be many terms and then plus nc0 into ncr, nc1 into ncr plus 1, and this series will continue and it will be ncn minus r into ncn, and all these terms, they'll have the power of x as x to the power n plus r. So generally in these questions, what will happen is the series that I'll need in the question, it'll come up with some particular power of x, which in this case is n plus r. So if I have to find the sum of this series, then I need to find the coefficient of x to the power n plus r from this expansion, which is 1 plus x to the power 2n, and the coefficient of x to the power n plus r on the left will be same as coefficient of x to the power n plus r on the right. So basically in this series, I need to find coefficient of x to the power n plus r. Now I know that 1 plus x to the power n, coefficient of x to the power r is ncr. So in this case, coefficient of x to the power n plus r simply will be twice n c n plus r. So answer to this question will be, so the coefficient of x to the power n plus r on the right hand side is this series that I need, and on the left hand side it is 2nc n plus r, And because this series corresponds to the same expression or the same binomial expansion, so these two terms, they should be equal. So answer to this series simply will be twice n c n plus r. Now there'll be many variations in that. In some question they'll ask you to find this c0, c1, c1, c2, and then cn minus 1 into cn. Now in this case, I know that clearly the value of r is simply 1. So if I'll put the value of r as 1, I'll get this series as 2nc n plus 1. And I also know that ncr is same as ncn minus r. So I'll simply write it as 2nc n minus 1. So either 2nc n plus 1 or 2nc n minus 1. Both of them, they are same. Another variation could be, they'll ask you to find this c0 square minus c1 square plus c2 square, sorry, c0 square plus c1 square plus c2 square plus cn square. Now in this case, it is c0 into c0, c1 into c1, cn into cn. So that is the value of r is simply 0. So if I'll put value of r as 0, I'll get this result as twice n cn. So these are the kind of series that we can solve using product of binomial coefficient when the difference of lower suffix is constant. Now another question is, we need to find the value of 30C0, 30C10 minus 30C1, 30C11, 30C2, 30C12 and 30C20 and 30C30. So again, if I look at the difference of suffix, it will be 10 here, 11 minus 1 is 10 again, 12 minus 2 is 10 and 30 minus 20 is 10. Now here there is a slight variation, that is here we have alternate positive and negative signs. So what I'll do is, I'll choose one of the series as 1 minus x to the power 30. So I'll write 30c0 minus 30c1x, 30c2x square, 30c3x cube, and then it'll be 30c30 into x to the power 30. And I'll choose other series as x plus 1 to the power 30. So here I'll write 30c0 x to the power 30, 30c1 x to the power 29. Now I'll need to multiply 30c0 with 30c10. So I'll write 30c10 and 30c10 will be x to the power 20, 30c11, so there'll be x to the power 19, 30c12, x to the power 18, and then finally it'll be 30c30 into x to the power 0. So now I'll multiply these two series. Now one of them is a plus b and the other one is a minus b. So if I'll multiply them, I'll get a square minus b square. So I'll write 1 minus x square whole to the power 30. And here I'll have lot many terms, but I'll focus on the terms that I'll need. So the terms that I'll need is when 30c0 gets multiplied with 30c10. So 30c0 gets multiplied with 30c10, I'll get x to the power 20. Now when 30c1 gets multiplied with 30c11, so again x to the power 1 into x to the power 19 is x to the power 20. For the next one also, power 2, power 18, again sum is 20. So that is the series that I'll need in the question is nothing but coefficient of x to the power 20. So I'll write, so there'll be lot many terms and then plus. So if I'll multiply, I'll get 30c0 into 30c10 minus 30c1 into 30c11, and this series will continue and will continue up to 30c20 into 30c30. So when 30c20 gets multiplied with 30c30, again it will be x to the power 20 and then all other terms. So that is, this series is actually nothing but coefficient of x to the power 20. So in this case, I need to find coefficient of x to the power 20 on the left hand side. So I'll write its general term. So it is tr plus 1 and tr plus 1 is 30cr and minus x squared to the power r. So if I'll compare the two powers, so I'll get 2r equals 20. So the value of r is 10. So here in this case, the coefficient will be 30c10 into minus 1 to the power 10, which in fact is 30c10. So answer to this series is simply the coefficient of x to the power 20, which is 30c10. So it is 30C10, or maybe they'll give you the option 30C20. Both of them, they are same. NCR is same as NCN minus R. So when we have any condition where the difference between two suffixes is constant, then we can simply write the two expansions and then we can multiply the terms. And we'll have to look for the power of x with which I'll get this series, and we need to find that power of x from the left hand side. So if all the terms are positive, I'll just take 1 plus x and x plus 1. If terms are alternate, positive and negative, then I'll take one of the series with a minus sign and the other series with a plus sign. Now suppose the question is, we need to find the sum of this series, which is C1 square, 2C2 square, 3C3 square plus NCN square. So what I'll do is I'll add the missing term and there'll be 0 into C0 square, and I'll say this series is simply S. Now when I look at these coefficients 0, 1, 2, 3, n, it is an AP. So I think the best method to solve this one should be reversing technique. So I'll reverse the series. So if I'll reverse the series, I'll get n times Cn square, n minus 1 times Cn minus 1 square, and then 0 into C0 square. Now what I know is NCR is same as NCN minus R. So I'll write this series as n into C0 square, n minus 1 into C1 square, and will continue up to 0 into Cn square. Now I'll add the two series, and here it will be 2s, and 0 plus n will be n, 1 and n minus 1 again will be n and 0 will be n. So I'll take this n common, and then I'll get C0 square plus C1 square plus Cn square. So the sum of the series is n by 2 into C0 square plus C1 square plus Cn square. Now in one of the previous videos, we have already worked this out, and this is kind of like standard series. So you must remember this result, which is C0 square plus C1 square plus Cn square. It is 2NCn. So I can write it as simply 2NCn. So if I'll further expand, I'll write n by 2 factorial 2n factorial n and factorial n. So I'll write n. Here I'll write 2n into factorial 2n minus 1. Here will be 2, and I'll write n into n minus 1 factorial and n into n minus 1 factorial. So n will cancel, 2 will cancel, and this n will also cancel. So I can write it as factorial 2n minus 1 upon factorial n minus 1 whole square. So answer to this series is factorial 2n minus 1 upon n minus 1 factorial whole square. Now let us take another question, which is I need to find C0 square plus C1 square upon 2, C2 square upon 3, and Cn square upon n plus 1. So here it's a product of binomial coefficient, and also what I see is it is C0 upon 1, C1 upon 2, C2 upon 3, Cn upon n plus 1. And if you'll recall that integration method, that if I'll integrate 1 plus x to the power n, then I'll get this series, which is C0 upon 1, C1 upon 2. So I'll start with 1 plus x to the power n, and I'll write C0, C1x, C2x square, and then Cnx to the power n. So now I'll integrate. So I'll write it as integration of 1 plus x to the power n into dx, and I'll integrate from 0 to, I need the powers of x, so I'll integrate from 0 to x. So it'll be from 0 to x, C0 dx, 0 to x, C1x dx, 0 to x, C2x square dx, and then finally 0 to x and Cn x to the power n dx. Now if I'll integrate this one, I'll get 1 plus x to the power n plus 1 upon n plus 1 from 0 to x. And here I'll get C0 x upon 1, C1 x square upon 2, C2 x cube upon 3, and then it will be Cn and x to the power n plus 1 upon n plus 1. So I can write this expression as 1 plus x to the power n plus 1, and then minus, if I'll put 0, I'll get 1 upon n plus 1, and this is equals to C0 x, C1 x square upon 2, C2 upon 3x cube, and then Cn upon n plus 1 into x to the power n plus 1. Now I need to multiply C0 with C0, C1 with C1, and C2 with C2, and because the difference is same, so I'll take the expression x plus 1 to the power n, and I'll write its expression. So I'll write its expansion. So I'll write C0 x to the power n, c1 x to the power n minus 1, c2 x to the power n minus 2, and then cn into x to the power 0. Now I'll multiply these two series. So when I'll multiply, I'll get this result as 1 plus x. Now it is to the power n and then multiplied with n plus 1. So it will be 2n plus 1 and then minus x plus 1 divided by n plus 1, and on the right hand side I'll ignore all other terms. What I need is simply c0 square, so I'll multiply c0 with c0, c1 with c1, c2 with c2, and cn with cn. So here if I'll multiply them, I'll get x to the power n plus 1. Here also I'll get x to the power n plus 1. Here again x to the power n plus 1, and here again x to the power n plus 1. So the series that I'm looking for, it is nothing but the coefficient of x to the power n plus 1. So I'll write it as c0 square, c1 square upon 2, c2 square upon 3, cn square upon n plus 1 into x to the power n plus 1. So in order to find the answer to this series, all I need to do is I'll just have to find coefficient of x to the power n plus 1. Now I won't get any coefficient from this one because here the highest power is n. So if I'll take coefficient of x to the power n plus 1 from this expression, it will be 2n plus 1 cn plus 1, and then I'll also have this expression which is 1 upon n plus 1. So answer to this series simply will be 2n plus 1 cn plus 1 upon n plus 1. So I can further write it as 2n plus 1 factorial. This is n plus 1, and here will be factorial n plus 1 and then factorial n. So n plus 1 into factorial n, I can write it as 2n plus 1 factorial, and this is n plus 1 factorial into n plus 1 factorial. So I'll write n plus 1 factorial whole square. So answer to this question is 2n plus 1 factorial upon n plus 1 factorial whole square. So when we have multiplication of binomial coefficient, then every time we'll have to multiply at least the two given series. But then there may be questions where rather than taking the simple expansions of 1 plus x and x plus 1, there may be questions where we need to differentiate a series and then multiply, or maybe integrate a series and then multiply the terms to get the requisite series. Another possibility that we have when we consider product of binomial coefficients in binomial series, it is when sum of the lower suffix of the binomial coefficient is constant. So previously the difference was constant, now here the sum is constant. Say for example, it is 0 plus n, it's n, 1 plus n minus 1, again n, 2 plus n minus 2, again n, and then it continues up to n plus 0, which again is simply n. Now in this case, again we'll start with the expansion of 1 plus x to the power n. So simply it will be c0 plus c1x, c2x square, and then cn minus 1 x to the power n minus 1 plus cn into x to the power n, and again I'll take the expansion of 1 plus x to the power n. So in this case, I need not reverse the series because already sum is constant, right? So again I'll write c0 plus c1x plus c2x square, cn minus 1 x to the power n minus 1, and then cn into x to the power n. Now I'll start multiplying them. So if I'll multiply it, I'll get 1 plus x to the power 2n, and then I'll need to multiply this c0 with cn. So I won't bother about other terms. So when I'll multiply c0 with cn, I'll get x to the power n. When I'll multiply c1 with cn minus 1, so it is x to the power 1 and it is x to the power n minus 1. So again it is x to the power n. So plus c1 into cn minus 1. So again then c2 into cn minus 2. So it'll continue, and finally c0 into cn, again it'll come with coefficient of x to the power n. So that is, if I have to find the sum of the series, then all I need to do is I'll just need to find coefficient of x to the power n on the left hand side. So I need to find coefficient of x to the power n. So what is the coefficient of x to the power n in 1 plus x to the power 2n? So coefficient of x to the power n simply will be 2n cn. So coefficient of x to the power r in 1 plus x to the power n is ncr. So that is 2n Cn. So that is the answer to this question. And I can also write this result as, I know that NCR is same as NCn minus R. So NCn will be NC0, NCn minus 1 is NC1, NCn minus 2 is NC2. So the same result can be written as C0 square plus C1 square plus C2 square and plus Cn square again will be 2NCn, which is again same as the case where the difference of suffix is constant, right? So this is the alternate expression of the same series. Let us consider another binomial series, which is MCR into NC0, MCR minus 1 into NC1, MCR minus 2 into NC2, MC0 into NCR, and we have to prove that it is equal to M plus NCR. Now in this case, when I look at the sum of suffix, it is R. Again, R minus 1 plus 1 is R minus 2 plus 2 is again R, and then 0 plus R is again R. So that is sum of lower suffix of binomial coefficients is constant. So I'll write the expansion of 1 plus x to the power m. So it is MC0, MC1x, MC2x square. And because I need MCR and MCR minus 1 and MCR minus 2, so I'll write plus MCR minus 2 into x to the power r minus 2, MCR minus 1 x to the power r minus 1 plus MCR into x to the power r, and then all these terms will continue up to MCM into x to the power m. Now I'll also consider the sum of this series, which is 1 plus x to the power n. So in this case, it will be NC0, NC1x, NC2x square. Now I need to multiply it till NCR. So it will be NC r minus 1 into x to the power r minus 1, and then it will be NCR into x to the power r. Now I'll start multiplying them. So if I'll multiply them, then I'll get 1 plus x to the power m plus n. And here on the right hand side, I'll ignore all other terms. So I'll go for what I need. So what do I need? I need MCR to multiply with NC0. So when I'll multiply MCR with NC0, so I'll get MCR into NC0, and it will be the coefficient of x to the power r. Now the next one is MCR minus 1 and NC1. So MCR minus 1 and NC1. So it is x to the power r minus 1, and this is x to the power 1, which again is x to the power r. So this is MCR minus 1 into NC1. So the series that I need, so this series, it is nothing but it is coefficient of x to the power r. So if I have to find the sum of this series, all I need to do is I'll just need to find coefficient of x to the power r from this left hand side. So what is the coefficient of x to the power r in 1 plus x to the power n? It is simply NCR. So n in this case is m plus n. So the coefficient of x to the power r simply will be m plus n CR, and that's your result, which is m plus n CR. Now there is another way of solving this question, and which is using combinational argument. Now suppose I have two separate group of distinct objects. So in first group, let there be m objects, and in second group, let there be n objects. So we have altogether m plus n distinct objects. Now I have to select r objects from these m plus n objects. So I have to select r objects from these m plus n distinct objects. Now in how many ways can it be done? So we clearly know that if I have to select r objects from n objects, then it can be done in NCR ways. So if I have to select r objects, then it can be done in m plus n CR ways. Now another way of doing it can be if I'll select r objects from m and 0 objects from n, or I may select r minus 1 from m and 1 from n. It could be r minus 2 and then 2, and I'll continue up to here if I'll choose 0, and here if I'll choose r. So for the first case, in how many ways can I select it? So it'll be MCR and then NC0. For the second case, it'll be MCR minus 1 and then NC1. mcr minus 2, nc2, and here will be mc0 and ncr. So if I'll add them, so again I'll get all the possible ways in which I can select r distinct objects from given m plus n objects. So these two scenarios, the one on the left where we have taken each distinct case, and also on the right where we have taken r distinct objects from m plus n object, they both represent the same scenario, right? So in this case, both of them, they ought to be equal. So mcr nc0, mcr minus 1 nc1, and mc0 ncr, it is equal to m plus ncr. So we can also solve this question using combinational argument. Now there may be questions in multinomial theorems also where we need to find product of coefficients. Say for example this one. So we are given the expansion of 1 plus x squared to the power n, which is a0, a1x, a2x square, a3x cube, and a2n x to the power 2n. And I need to find the product of a0 square. So I need to find the series which is a0 square minus a1 square plus a2 square, and then plus an square. So I'm multiplying a0 with a0, a1 with a1, a2 with a2. So that is difference between two suffix is constant, right? So now I'll start with the first series, which is 1 plus x square to the power n. So here I'll write it as a0 plus a1x, a2x square, a3x cube, and here will be a2nn x to the power 2n. Now I need to reverse the series. Now I cannot reverse the series as we have done in binomial, because in multinomial we cannot reverse the series, or we cannot reverse the terms to get the same expansion. So what I'll do is I'll replace x with 1 upon x. So if I'll replace x with 1 upon x, then this term will be 1 upon x to the power 2n, so which will come with a0. So in case of multinomial expansions, so we have to replace x with 1 upon x, and because there is an alternate plus or minus sign, so in fact I'll replace x with minus 1 upon x. So if I'll replace x with minus 1 upon x, I'll write 1 minus 1 upon x plus 1 upon x squared to the power n, and it will be a0 plus a1 minus a1 upon x plus a2 1 upon x square minus a3 1 upon x cube, and will continue, and will be a2n and 1 upon x to the power 2n. Now I'll multiply the two expressions. So if I'll multiply the two expressions, so I'll write 1 plus x square to the power n, and here I'll take x square LCM. I'll write x square minus x plus 1 to the power n, and here there'll be lot many terms, but then I'll just focus on the term or the series that I need. I need a0 square. So if I'll multiply a0 with a0, I'll get a0 square, and then minus a1 into a1 is a1 square. So a0 square, it is term independent of x. Again, a1 gets multiplied with a1, again independent of x. X square, 1 upon x square, x cube, 1 upon x cube, x to the power 2n, and x to the power 1 upon 2n. So that is the series that I need in this expression is actually coefficient of x to the power 0. So from this series, so if I have to find the answer to this series, which is a0 square minus a1 square plus a2 square, this series has to be coefficient of x to the power 0. So from this series, I'll need to find coefficient of x to the power 0. So what I'll do is I'll multiply them. So it is a plus b and a minus b. So I'll write 1 plus x square whole square, and then minus x square to the power n divided by x to the power 2n. So if I'll further simplify, I'll write 1 plus x square plus x to the power 4 to the power n upon x to the power 2n. So from this series, I need to find coefficient of x to the power 0. Now, how do I find coefficient of x to the power 0? I know that there is x to the power 2n in the denominator. So whatever I'll get from the numerator, it will be cancelled or it will be subtracted by this power of x, which is x to the power 2n. So in order to get x to the power 0, I need to find out coefficient of x to the power 2n in the expansion of 1 plus x square x to the power 4 to the power n, or I can write it as I need to find coefficient of x square to the power n in 1 plus x square whole square to the power n. If I look at this series, 1 plus x square, Here it is 1 plus x square whole square. So if I replace x with x square, I'll get 1 plus x square plus x to the power 4 to the power n. So I'll get a naught, a1 x square, a2 x to the power 4. And here this term will be an x to the power 2n and then a2n x to the power 4n. Now what I'm looking for? I'm looking for coefficient of x to the power 2n. So in this series, coefficient of x to the power 2n is simply an. So that is coefficient of x naught on the left hand side will be nothing but an. So therefore, answer to this series, a naught square minus a1 square plus a2 square plus an square is nothing but an. So we may get questions when we multiply coefficients in multinomial theorem also. Now there may be some series where we need to find product of binomial coefficients with variable upper indices. Say for example, now in this case it is nc0 and then 2ncn, nc1 and then 2n minus 1 cn, 2n minus 2 cn, and then it goes up to ncn. So if I look at these terms like 2ncn, 2n minus 1 cn, so we have variable upper indices. So what I can say is this 2ncn, it is coefficient of x to the power n in the expansion of 1 plus x to the power 2n, 2n minus cn. In the same way I can say it is coefficient of x to the power nn, 1 plus x to the power 2n minus 1. So finally I can say this ncn is coefficient of x to the power n in 1 plus x to the power n. So what I'll do is I'll simply say, now this series I'll get, if I have to find coefficient of x to the power n in nc0 into 1 plus x to the power 2n. So from this series I'll get the coefficient of x to the power n. So there'll be 2ncn. So it'll be nc0 into 2ncn and then minus nc1 1 plus x to the power 2n minus 1 plus nc2 1 plus x to the power 2n minus 2, and finally I'll get minus 1 to the power n ncn into 1 plus x to the power n. Now what I'll do is I'll take this 1 plus x to the power n common. So if I take this 1 plus x to the power n common, I can write nc0 1 plus x to the power n minus nc1 1 plus x to the power n minus 1 plus nc2 1 plus x to the power n minus 2, and this series will continue up to 1 to the power n and ncn. Now if I look at this series is actually nothing but it's a binomial expansion of nc0 x to the power n minus nc1 x to the power n minus 1, nc2 x to the power n minus 2. So in fact it is the binomial expansion of x, which in this case is 1 plus x minus 1 to the power n. So I need to find coefficient of x to the power n in the expansion of 1 plus x to the power n into x to the power n. Now since I already have this x to the power n, so that means I need to get the coefficient of x to the power 0 from this series. So coefficient of x to the power 0 will be nc0, which is 1. So the answer to this given series is simply 1. So this is how we solve questions involving binomial coefficient with variable upper indices. So let us take another question, which is we need to find the sum of this series, which is nc0 2ncr minus nc1 2n minus 2cr, nc2 2n minus 4cr, and this series will continue. So here in this case, when I look at these terms 2ncr, it is coefficient of x to the power r in the expansion of 1 plus x to the power 2n. In the same way, it is coefficient of x to the power r in the expansion of 1 plus x to the power 2n minus 2. And here will be x to the power r in 1 plus x to the power 2n minus 4. So eventually I'll write, so this series is actually coefficient of x to the power r in the expansion of nc0 1 plus x to the power 2n minus nc1 1 plus x to the power 2n minus 2, nc2 1 plus x to the power 2n minus 4, and this series will continue, and finally it will be NCN into 1 plus x to the power 0. So from this series, I need to find coefficient of x to the power r. Now, if I look at this series, now this series is actually nothing but nc0 into 1 plus x whole square to the power n. And then it will be 1 plus x whole square to the power n minus 1. So which again is nc0 x to the power n minus nc1 x to the power n minus 1. So basically what I need is coefficient of x to the power r in the expansion of, so now x in this case is 1 plus x whole square minus 1 to the power n. So from this series, I need the coefficient of x to the power r. So it will be coefficient of x to the power r n. So 1 and 1 will cancel. I'll get 2x plus x squared to the power n. So I'll write coefficient of x to the power r n, x to the power n, and 2 plus x to the power n. Or basically I can say coefficient of, now every term from this gets multiplied with x to the power n. So basically I need to find coefficient of r minus n in the expansion of 2 plus x to the power n. Now in the first case, if r is less than n, in that case, there will be x to the power some negative number. So there will be 1 upon x something, and I cannot get 1 upon x something in the expansion of 2 plus x to the power n. In that case, coefficient of x to the power n minus r in this series will be 0. That is, the answer to this series in that case will simply be 0. Now in the second case, when the value of r is greater than or equal to n, then if I write its general term, suppose tk plus 1th term, so there will be nck 2 to the power n minus k and x to the power k. Now I need the coefficient of r minus n. So I'll simply take k as r minus n. So in that case, coefficient of x to the power n minus r simply will be, so nc r minus n and then 2 to the power 2n minus r. So if r is greater than or equal to n, then the answer to this series will be ncr minus n 2 to the power 2n minus r. So there will be two cases, when r is less than n or when r is greater than or equal to n. Let us take another one, in which is find the sum of the series nc0, nc1cn, nc1, ncn minus 1, and the series continues up to ncn and 1c0. Now this question is different from the previous two questions. So in the previous two questions, it was variable upper indices, but then lower index, it used to be same. But in this question, we have upper indices which are varying, and we also have lower indices that are varying. So what I'll do is, I'll write the same series, but I'll write it in reverse, and then when I'm reversing the series, I'll change the first coefficient, I'll keep the second coefficient same. So I'll write it as nc0, and there'll be 1c0 plus nc1, and there'll be 2c1, nc2, 3c2, and then here will be ncn and then n plus 1 cn. Now I'll add the given two series. So if I'll add them, I'll get 2s, and it will be nc0. So this is n plus 1 cn plus 1 c0, nc1, ncn minus 1 plus 2c1, nc2, n minus 1 cn minus 2 plus 3c2 and plus ncn. So there will be 1c0 plus n plus 1 cn. Now if I look at this pattern, then this pattern is n. So if I write this one as r plus 1 cr, so here will be n minus r, and here it should be n minus r plus 1. So if I'll simplify this pattern, I'll get n minus r plus 1 factorial upon factorial n minus r, and here will be factorial r plus 1 upon factorial r. So I'll cancel factorial n minus r, so I'll get n minus r plus 1 and then r plus 1. So here I'll get this as n plus 2. So in each of these expressions or in each of these factors, the sum of these two terms will always be constant, and that should be n plus 2. So I'll take this term n plus 2 common from each of these terms. So I'll write n plus 2, and then all I'm left with is nc0. So 2s is equal to n plus 2, and then nc0 plus nc1 plus ncn. So there'll be 2s into n plus 2, and there'll be 2 to the power n, and this is n plus 2 to the power of n minus 1. Now another way of looking at the same question can be, I can write this series as nc0, and this is n plus 1 c1, nc1, this is nc1, nc2 will be n minus 1 c1, and then ncn, and that is 1c0. So in each of the case, it is nothing but nc1, and nc1 is simply n. So I can actually write it as n plus 1 c0, nc1, n minus 1 c2, and then finally it will be 1 into ncn. And these coefficients, they are nothing but an arithmetic progression, and that is the reason we have used reversing technique in this question. So this is another way of solving the same problem. Now there will be some questions which are based on properties of binomial coefficients. So we'll take up some series where we'll need to use binomial coefficients property. Like say for example, the question is summation r varies from 0 to n minus 1, and that's ncr divided by ncr plus ncr plus 1. Now when I look at this expression, I know that here I can use the property where n is same and r differs by 1. So I can simply write it as, so that's summation r varies from 0 to n minus 1, and that's ncr. Now it will be n plus 1 c r plus 1. So now I'll use the definition of ncr. So I can write it as summation r varies from 0 to n minus 1, and here will be factorial n, factorial r, factorial n minus r, and here I'll write it as factorial n plus 1, factorial r plus 1, and then again factorial n minus r. So I'll cancel this n minus r with n minus r. Now this factorial n and factorial n plus 1, I can cancel factorial n, and for this factorial r and factorial r plus 1, I can cancel factorial r. So actually I'll write it as summation r varies from 0 to n minus 1, and there will be r plus 1 upon n plus 1. Now summation is in terms of r, not in terms of n. So I can actually take this n plus 1 out. So if I take it out, I can write it as 1 upon n plus 1. And then this summation starts from 0 and it goes all the way up to n minus 1, and it is r plus 1. And if I essentially look at this series, it is nothing but, if I put r as 0, it is 1. So it is 1 plus 2 plus 3. And it goes up to, when the value of r is n minus 1, so minus 1 and plus 1 will cancel, so it will be n. So sum of first n natural numbers, so it is n plus 1 and then n into n plus 1 by 2. So n plus 1 and n plus 1 will cancel. I'll get this result as n by 2. So in this question, we have used this binomial coefficient property, which is ncr plus ncr minus 1, and that's n plus 1 cr. Here the question is, find the sum to n terms of the series factorial m plus factorial m plus 1 by factorial 1 plus m plus 2 upon factorial 2, and then n plus n minus 1 upon factorial n minus 1. So what I'll do is, I'll take this factorial m common, so I can write it as factorial m, and here will be 1 plus m plus 1 factorial upon factorial m factorial 1, m plus 2 factorial upon factorial m factorial 2, and continue up to m plus n minus 1 factorial upon factorial m factorial n minus 1. Now I can write 1 as m plus 1 c0, and here the second expression is nothing but m plus 1 c1. So I'll write it as m plus 1 c1. Second one will be m plus 2 c2, m plus 3 c3, and finally I'll get m plus n minus 1 c n minus 1. Now if I look at first two terms, here n is same and r differs by 1. So if I'll add them, I'll get it as n plus 2 C1. Now here again, n is same, r differs by 1. So I'll write it as n plus 3 C2. Now again, m plus 4 C3. So eventually, I'll get this result as factorial m because it's already there. It's being multiplied to every term. And then finally, I'll write it as m plus n C n minus 1. So I can also write it as factorial m plus n, factorial n minus 1, and it will be factorial m plus 1. So I can cancel factorial n. So I'll write it as m plus n minus 1 factorial into m plus 1. So let us take up another question, and that is we need to simplify this given expression, which is nc1 plus n plus 1 c2 n plus 2 c3 n plus m minus 1 cm, and in the denominator also we have like similar kind of series, right? So I'll take up the first series, and which is nc1 plus n plus 1 c2 n plus 2 c3 and n plus m minus 1 cm. So I'll add nc0, and because I've added it, I have to subtract it also. So I'll subtract nc0. Now if I look at these first two terms, so n same, r differs by 1. So I can write it as n plus 1 c1. Now here again n same, r differs by 1. So it will be n plus 2 c2. If I'm going to carry out the operation for all the terms, then in the end I'll get n plus m cm minus 1. So for the series in the numerator, I'll get this result as n plus m cm minus 1, and the series in the denominator, it is same as series in the numerator. It's just that we have interchanged m and n. So I'll get the same result, but the result here will be m plus n cn minus 1. Now what I know is ncr is same as nc n minus r. So essentially n plus mcm is same as m plus ncm. So basically these two terms, they are same, so they'll cancel out. So answer to this series is simply, or answer to this expression is simply 1. Now we look at some of the questions related to the properties of binomial coefficient, which is ncr upon ncr minus 1, and that is n minus r plus 1 upon r. Now in this case, I'll write the general term, which is k cube, and that's nck upon nck minus 1. So what I know is ncr upon ncr minus 1, I can write it as n minus k plus 1 upon k. So now square of that. So I need to square it. So I'll cancel this k square. So I'm left with k. So here will be k. And here I'll write it as n plus 1 minus k whole square. So it will be k n plus 1 square plus k square minus 2 n plus 1 into k. So I'll multiply this k inside. So I'll write n plus 1 whole square into k plus k cube minus 2 n plus 1 into k square. Now I need to find sum of all these terms. So I'll take the summation. So sum of first n terms is simply summation. K varies from 1 to n, and that should be n plus 1 square k plus k cube minus 2 n plus 1 into k square. So that is n plus 1 square n plus 1 by 2. Summation k cube simply will be n plus 1 by 2 whole square, and then 2 times n plus 1, and summation k square is simply n plus 1 2n plus 1 whole divided by 6. Now what I'll do is I'll take this n and n plus 1 whole square common, and I'll also take this 2 common. So I'll write n plus 1 whole square by 2. So then I'm left with n plus 1. Here I'll get n by 2, and here I'll get 2 by 3 into 2n plus 1. So now I'll take LCM. So if I take LCM, I can write it as n plus 1 by n plus 1 whole square by 2, and here will be 6n plus 6 plus 3n minus 8n minus 4 whole divided by 6. So eventually it will be n plus 1 whole square, and then 9 minus 8 is simply n, and then it will be n plus 2, and 6 into 2 is 12. So it will be n plus 1 whole square, n plus 2 divided by 12. If you like the video, consider subscribing and sharing it with someone you know who might benefit from it. Also, the best way to navigate any topic is through a playlist. Simply go to the channel page, click playlist, and select the topic you wish to study.